About to start. And now we're starting our second day of IEEE PowerTalks, session 4, Assistant Management and Optimization, chaired by Mohammed Sulaiman Al-Ghanemi, General Manager Planning from Nama Electricity Distribution. Please come to the stage.
Assalamu alaikum. I think we need to get started. Still the room is half capacity. I'm expecting a full capacity after today's full agenda and you get refreshed and energized. But anyway, we can get start with the existing audience. Bismillah ar-Rahman ar-Rahim. Good morning, distinguished guests, colleagues, and friends. It's a pleasure to welcome you all to session number 4, Asset Management and Optimization, here at IEEE PowerTalks 2025 in Muscat. My name is Mohammed Al-Ghanemi, and I will have the honor to moderating this exciting session. Asset management is actually of my favorite topics. I used to work in asset management, but I'm not wearing that hat anymore. But it's still in my blood. It's part of my DNA. Asset management, at its core, is both an art and science. The art of balancing priorities and the science of making the right decisions. In our fast evolving energy sector, managing assets is no longer just about upkeep. It's about optimizing performance, resilience, and strategic value as we transition towards smarter, cleaner power systems. In this session, inshallah, we will hear from 6 distinguished speakers, each bringing a unique perspective from strategic decision-making models and transformer health analytics to real-time monitoring, energy efficiency, and renewable integration. Each speaker will present about 15 minutes, so I will promise that I'm not going to interrupt, so please support me. After which, we'll gather for a short panel discussion and Q&A. Please note your questions as we go. It is the morning session, and we are not standing between you and the lunch, and we are not after a lunch session, so I think you are a bit energetic, so you can ask more questions. We need the two-way interaction between the panelists and the audience. I think that will give the session more, it will be more valuable. So to kick off our session, I'm pleased to introduce Ms. Shanouna Al-Aisri, Senior Specialist in Energy Excellence at OQ Alternative Energy. Shanouna Al-Aisri is a Specialist Energy Excellence Engineer working with the Energy Excellence team in OQ Alternative Energy. She has expertise in ISO 5001, Energy Management Certification and Process, and has successfully delivered certification for OQ Corporate and is currently working with other OQ entities for establishing energy management system. Today, she will present on how energy management standards drive operational excellence and sustainability. Please join me in welcoming Shanouna to the stage.
Thank you, Mohammed. Assalamu alaikum. Good morning. My name is Shanouna Mohammed Al-Aisri from OQ Alternative Energy. I'm delighted to be here today to speak about Integration Energy Efficiency Program with ISO 50001. And I'm happy to see you all here to make this event a success. So I'm Senior Specialist Energy Excellence from OQ Alternative Energy. Where our main and strategic mandate is to drive Oman's energy transition. So OQ Alternative Energy is a catalyst to achieve the national objectives. In addition to that, it is the national champion for the renewable energy. Its mandate is to develop portfolio for clean energy, lead the decarbonization efforts, leads the diversification into new energy sectors, and build national capabilities within Oman. OQ Alternative Energy also through its Energy Excellence Department leads the ISO 50001 certification and implementation across its assets. Okay. So some of you might wonder, what is ISO 50001? ISO 50001 is an international energy management standard that was established back in 2008 when the United Nations recognized the urgent need for industries around the world to take an urgent action to respond to the global warming. This standard was then updated in 2018, and since then we're using that updated revision of the standard. The ISO 50001 works as a framework to support organizations to monitor, control, maintain, and minimize their energy consumption. Like the other ISOs, this ISO follows the PDAC cycle, which is the Plan, Do, Check, and Act cycle, where you would start with the plan phase through obtaining your top management commitment, define the scope and work, the scope and boundaries, develop the energy policy, and promote your employees' awareness and engagement. There is one key element in this phase, which is the element number 6, the planning element. This element actually asks you to set your energy KPIs and objectives, conduct the energy review or an energy audit in order to identify your significant energy users and your performance indicators as well. You set your baseline, and then you move on to look into different opportunities to maintain your system and minimize the energy consumption of your system. The second phase, which is Do phase, is where you actually execute your action plans, deploy the monitoring, metering, and measurement systems as well. In addition to that, you would consider energy efficiency in your operations, procurement, and design processes as well. For the Check phase is where you monitor your performance against the baseline that you have set. You evaluate the effectiveness of the actions that you have taken. And in addition to that, you would conduct the internal audit and communicate the findings to your top management. The last phase is the Act phase, is where actually you conduct the management review meetings and you integrate the lessons learned for continuous improvement. And in addition to that, you would certify your assets, because the certification normally happens and takes place in the Act phase. So when we talk about the benefits, we have received lots of encouraging testimonials from the assets that have implemented ISO 50001, where they managed to boost their energy efficiency, minimize their CO2 emissions to the atmosphere. They also managed to minimize their operational costs, and they gain trust and reputation in the market. So when we talk about investor relation, lots of listed companies that have implemented the ISO 50001 managed to enhance their investor relations through deploying the ISO 50001 implementation and certifications outcome to be as an input to their sustainability reports that they would share with their ESG-focused investors through highlighting several things like the mitigated risks, the reduced carbon footprint, the improved operational savings margins, and the positive competitiveness out of holding the ISO 50001 certification. Okay, so these are the main areas covered under ISO 50001 standard. The standard actually covers lots of areas, starting with the energy policy, which actually makes sure that the energy use remains an integral part of your organization, all the way to the continuous improvement, where this highlights your ongoing efforts to enhance processes, performance, and the outcomes over the time through innovational changes. Okay? As you may see here, that ISO 50001 can be applicable across various sectors or across various industrial sectors. That is because it is flexible. It is process-based framework focusing on energy management. It also aligns with the decarbonization and energy targets, including the Oman net zero vision. Okay. ISO 50001 also can be applicable in power generation, where applying this standard in power generation systems will allow you to have better monitoring and tracking of your systems, therefore spotting the issues early and taking the actions to improve your operations, maintaining your system through using the data to prevent breakdowns, optimize settings where you could adjust parameters in order to have less waste and better performance of your operations. Fuel quality, where this ensures that you're using good fuel type for your operations to have efficient burning and less emissions to the atmosphere. And then you have the heat recovery, is where you capture the waste heat in order to boost your energy use. And then this standard will also focus on the training and advanced controls. So all these will result in reduced fuel consumption per unit of power produced, lower emissions through optimized combustions, extended equipment life, therefore minimizing the maintenance cost, and increase the overall thermal efficiency of your gas turbines. Okay. ISO 50001 is also applicable in gas free-up processes, where these processes actually focus on optimizing energy through minimizing the gas use in these assets or in these processes. Therefore, implementing ISO 50001 in gas free-up processes will actually ensure the identification of energy-saving opportunities and continuous improvement through implementing lots of projects like heat recovery projects, electrification projects, process optimization projects, installations, and looking for alternative fuels to be used. So how is this important for Oman? Well, we are expecting to have shortage in the future. Therefore, implementing these type of projects in Oman will actually help us to introduce new industries in Oman. In addition to that, it will make sure that we have, or we're ensuring the energy security for the future. Okay? Because the demand is increasing, therefore we need to ensure energy security. So OQ has recognized the importance and the value of implementing ISO 50001. It has also successfully certified some of its assets with the support of Energy Excellence team. And additional assets are coming in the pipeline to be certified, inshallah, hopefully by end of this year. And more are expected to follow in the next year. OQ has also made great achievements in terms of minimizing the operational cost and minimizing its carbon reduction through optimized processes and through the adapting of global best practices. I believe it's worth mentioning I believe it's worth mentioning that one of OQ assets have achieved a saving of more than 30 million USD since they have set the baseline in 2021 with more than 9,000 K CO2 equivalent reduction of CO2 emission. So moving to the culture, where OQ has embedded the energy efficiency culture into the core of its employees' mindset. Therefore, this became part of our DNA in OQ, where this should be actually something that you would practice in daily, weekly, monthly, and yearly basis, and not just a box that you would take complete. Okay? And as a conclusion, I believe we're all aligned on the importance of implementing ISO 50001 and the value that it brings. Therefore, I would encourage you to start planning for implementing this powerful standard in your assets. And we're always happy to support you with whatever doubts, questions, or even requests to support in the implementation of ISO 50001 for your assets. Yeah, that's it from my side. Thank you so much and have a great day. Thank you. طيب يعني أشوف عليه؟ شكرا.
Thank you, Shanuna. It's really insightful. It shows the importance of any management system, which is, it might be related to energy management, asset management, quality management, but it positions the organizations in, it's like in any international context, it's support to benchmark the any organization with the best practices. So thank you, Shanuna. So our next speaker, inshallah, is the engineer Yusuf Al-Hadi. Yusuf is a senior engineer, asset performance at Nama Distribution Company. With over 15 years of experience in asset management, power generation, and water desalination, Yusuf brings deep practical insight into performance optimization. Today, he's going to present on the Transformer Health Check, HI model, and how it helps utilities move from reactive to predictive maintenance. So welcome, Engineer Yusuf, to the stage.
Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning. Today I'm going to present Transformer Health Index model that designed and built at NEDC in-house. Transformer Health Index is a diagnostic model that helps and supports predictive maintenance and support performance of the transformer. Today we'll start with the introduction and the concept behind that development. And briefly we'll explain the maintenance strategy at NEDC. And I will give you an overview about the portfolio of the asset at NEDC. After that, we will explore the model design and the methodology being used for the calculation and to build that model. And before we conclude, we will go through the future enhancement and the challenge we faced during the build that model. So, what is Transformer Health Index? Transformer Health Index is a tool that used to predict and diagnose the failures before it happened. So, it integrates different parameters from the operational and from the environmental into a single score as a health index. It supports predictive maintenance before any failures, so you can plan the scheduling, the planned maintenance, before any outage or just minimizing the time for the preventive maintenance. The health index models, it's a data-driven decision. It combines operational parameters with the online data into a single score. Here an overview, just to give you a picture about how volume is that NEDC statistical data. NEDC operate and maintain over 200 kilometer square, 200,000 kilometers square, with over 1,400 power transformer of capacity 1 MVA to 20 MVA, manufactured since 18th, 19th, till date. Actually, it was a challenge for us to prepare any preventive maintenance plan or predictive maintenance with a huge asset. So that's why we have designed that tool, which is Transformer Health Index. So first, I will give you an overview briefly about the maintenance strategy at NEDC, which is the source of the data which has been involved for that model. Normally, I will focus on power transformer only. Normally, we have several categories for the power transformer. It depends on the age of the transformer and manufacturing year and the location of the transformer. Based on that, we have several categories for predictive maintenance. We are talking about dissolved gas analysis, breakdown values, and thermal image and partial discharge. So we have categorized between 1 to 3 years. Every transformer should be covered. I mean, we should have a predictive DGA, breakdown, thermal image, at least within 3 years, one time for each transformer, except of the age transformer and the transformer which is located in harsh climate like Musandam or Al-Ashkhara area, which is supposed to be yearly. And once the data received and once inspection already done, for example, if there is any abnormalities or any critical issues, the engineer immediately he will assign work order for corrective maintenance. Otherwise, if the defect, it can be maintained within 2 to 8 months, it will be held as a preventive maintenance. But the issue is that to collect that data from Musandam to Al-Wasta, it's a huge data. And previously, we are taking the data through manual checklist. So it was very hard to analyze that one on time. So it will be a delay to do the predictive maintenance. That's why we have gone to the preventive maintenance. But with the health index model, we solved this issue. And now we are considering condition-based maintenance, not timely-based in NEDC. So previously, at NEDC, we are using a separate sheet based on Excel sheet, which is 100% manually entered data. And that Excel sheet old maybe 12 years, I think. That time, no smart automation, no sensors, no online monitoring tools. So imagine Excel sheet data that you need to collect it from Musandam to Al-Wasta, plus handwriting, and delay to receive those data. Till you receive it, you need 5 to 7 months just to analyze the data so that you can predict the maintenance. So this is the main slide at the presentation here. So actually, due to that challenge, what we have previously with the previous Excel sheet and the preventive maintenance, our technical team had decided to go further for a new health index model. And we brought several components in the market. But actually, most of them, they have advanced technology and which required investment huge on online sensors, online monitoring tools, plus most of the data are not captured in our strategy. That means they have to do some assumptions and to deactivate some parameters. So before we design that model, we have taken three frameworks. One is the base for that model is the Norwegian Model Health Index. It was advanced and a huge model, so we customized it to meet any DC requirement. The second framework was the engineering experience and engineering insights. Since we have transformers from 40 years, we have huge historical data, plus the outage management system and the engineering experience. We combined it as a framework. The third one, even with the Norwegian Health Index model and the engineering experience, we need some boundaries to keep our model internationally. So the third framework was international standards. We took ESTDM, IEC, and IEEE as the reference of standards to build that models. So that model is the stage one, which has been designed. Initially, because of the data availability and the practice at NEDC, we consider 4 parameters only at stage one. Oil quality, which includes acidity, hydrogen, H2O, and breakdown voltage, and dissolved gas analysis, which include hydrogen, methane, ethane, ethylene, acetylene, carbon dioxide, carbon monoxide. Plus the environmental condition like ambient temperature and the online data like the load and the oil temperature. So how we collect that data to the model? Actually, the model fully automated. There is no data entry manually. So as I explained in the maintenance practice, we have condition monitoring. We consider breakdown voltage and DGA and moisture to that model. And visual inspection like oil leakage, corrosion, plus the environmental itself. If there is any rain or any abnormality, that day the program will be cancelled. So no data will be captured in the abnormality of the climate. So here how we collect the data and to automate the system. The engineer at the site, they have a tablet or mobile application, which is GIS Survey 123. Once the RC reach that, the site, they will take the parameters directly to the mobile system. No data entry manually, no hard copies, no written data. After that, they will submit it at the local at the same time. There will be integration with other systems, enterprise asset management system and GIS system, to combine several data from several systems. The fourth step, which is validation. Actually, we have made several interlocks to avoid human errors. So the chance of human errors is very neglected, maybe 5% only, because we provide a framework and we provide interlocks for each data entry, for each field. So no chance for errors here. So the calculation will be the weightage and the factors of each element parameters. As we said, we have 4 parameters, DGA and oil quality, plus the additional information like age, and the external factors like the corrosion and oil leakage. We combined all these parameters into a single scoring, which is give us a health index. And all that automated in the system. Here an example how we calculate each parameter. The tables what you are seeing here summarized for the presentation. The actual tables 2 to 4 times double this one. Each one have been developed and prepared with the experience of our engineers, based on the data of the field and historical at NEDC. We have given the weightage based on the criticality of each gas here. Same thing we'll do for oil quality. The other parameters, which is oil temperature and age of the transformer, and physical condition. So the final score will be for each one, giving the condition score plus the condition, good, acceptable, need caution. If any health index, the result is high, for example, and you need further details, just to press that one, it will go back which factor based on that for the analysis. This is the model looks like at our NEDC. And the model, is, as I said, it is automated fully. Since the engineer at the site submit the result within 2 minutes, it will reflect to the model itself. The data here is dummy, just for the presentation, not actual. So if you find any critical risk, you can press that one and to go directly to the asset itself and the transformer itself, where is it the issue, for further analysis. So actually, as I said from the beginning, this is the stage one. There are a lot of areas for improvement, but since the model is 2 years age only, we didn't go further because not all the data was available. So area of improvement to integrate other factors like thermal image, partial discharge, tap changers, the cooling system. Based on the NEDC experience today, we have some issue with some spare parts of availability. And this will be considered as one of the factors for the health index itself for the model. As you know, the health index, it's not only predictive maintenance, it is a data-driven decision for any investment, future investment, for example, refreshment, disposal of the asset, replacement. So some factors are related for the investment. The next stage, inshallah, we will update that model to capture all manufacturer details. Plus, as I said to you, that the historical data for outage management system, it will support to capture the health index actually. For example, if that transformer have been tripped previously, that will affect the data. And type of that tripping issue or that outage, is it related to the transformer itself? There will be some categorization for each category. As we said, since we have more than 200,000 square area, there are some channels for collecting the data, for automated data actually. And plus the model to be more online, let us say minutes by minutes, we need some online condition monitors, which are costly and required infrastructure investment, especially for the network itself. But we hope, inshallah, in future, maybe it will be implemented, at least all the measurement sensor, like for moisture, oil temperatures, and the winding temperature. So, in conclusion, transformer health index model, it's a tool used to predictive maintenance and plus used for this data-driven investment. It supports us for any future investment, such as replacement and rehabilitation of that transformer. It is a risk-based model. It gives you insight to the transformer healthiness before any failure it's occurred. Thanks for this thing. Thank you.
It's really impressive, Yusuf. Modeling is basically data, technical experience with assumptions, and if you have it internally customized, that is a great achievement. Thank you very much for this insightful. Our next speakers is Engineer Mohammed Al-Samri, Manager of a new product development at Oman Cable Industry, and Engineer Mahdi Abdel Khaliq, Mere Technical Sales Manager. Mohammed Al-Samri graduated from Higher College of Technology in 2015, now known as University of Technology and Applied Science, with a bachelor degree in electrical power engineering. Mohammed began his career as a cable design engineer, and in just 6 years, rose to manage new product development, leading innovative solutions for power distribution, oil and gas, and renewable sector. Mahdi Abdel Khaliq is an electrical engineer with a master's degree in engineering management. He graduated from American University of Sharjah in UAE and completed his master's degree in UAE University in Al Ain. He is a natural leader with 17 years of experience and excellent record of accomplishments. He has extensive experience in planning, design, asset management, construction, and maintenance of distribution electrical equipment. Also, he has extensive knowledge of multiple industries and their needs, such as renewable energy, manufacturing, and asset condition monitoring. Please join me in welcoming Mohammed and Mahdi to the stage.
Thank you, Engineer Mohammed. Assalamu alaikum. Good morning, everyone. Today, we are going to talk about the importance of continuous monitoring systems in enhancing networks efficiency and reliability. Before I start, I would like to mention that cables are considered as the backbone of the electrical power network, and we should always ensure that we are making sure that cables are functioning the way that they are intended to. So, as you know, a lot of grid operators today face different challenges due to network expansion or complexity in the network. Also, we have different issues like different or severe weather conditions that are caused by the climate change. There is an increase in electrification, and with that, there is a fast expansion in the network. And this also introduced higher failure rates. Now, thanks to the advancement in the technologies, today we can understand those issues and also prevent them from happening with using continuous monitoring solutions. A lot of reasons why we should monitor the assets. The main reasons are the following. We monitor the assets to prevent failures and outages. Hotspots can be generated into cables by different reasons. For example, we have issues in the insulation, or we have bad connections in the system, or also it could be mechanical stress on the cables. Now we can avoid those issues from happening and converting into outages in the system. We can enable predictive maintenance because we understand the degradation of the cables and also other components of the system. And with this understanding of the degradation, we can work with the maintenance teams to work on the preventive maintenance without them turning into complete failures of the system. One main point is that we can extend the lifespan of the cable because we understand that we have issues in the system, and we can work or step in earlier to fix those issues before they destroy the complete length of the cable. We improve safety. Now, faults in cables can introduce different risks. Let's say, for example, we have fire hazards, we have electrical shocks, and we also have damage to other equipments. We can identify those issues and improve the safety, and also ensure that our system is operating within safe parameters. We also optimize the performance, and this is one of the most important, I think, reasons for monitoring the assets. Now, with monitoring systems, we have real-time database of the loading and also the temperatures of the cables. And with this, utilities can optimize the ampacity of the cables and also ensure that the cables are not overloaded when they're used. We reduce also operational costs. Here, because as we know, always preventive maintenance is always more cost effective than emergency repairs. Or let's say, for example, downtime losses in the system because of faults. Now, in all together, we can enhance the network's reliability and efficiency for a sustainable future. I can summarize all of those different reasons for monitoring systems into 3 main goals. What we want to achieve while using monitoring systems today is basically we want to increase the reliability of the network. We want to improve the efficiency and also utilization of the assets. And also we ensure that the assets are always available without any downtime or outages. Now I would like to invite my colleague Mahdi Abdel Khalaq to talk about different monitoring systems and their benefits. Thank you.
Thank you, Mohammed. Thank you very much. Basically, with data, we thrive. So we want to go to the data-driven and increase the data so that our decisions are much better in the future. One of the solutions, and I think the previous presentation could use it very much, is the portable partial discharge solution. What is the benefit of this solution? It is a wireless solution, so you can take the measurement with an iPad. It is portable. It has a very sensitive sensor and accurate as well. There is no galvanic connection, so it's safe for the usage. Now, to be more and to understand more about your asset and understand what's going on, you need data. How do you do that? You need to get the data from, for example, the continuous partial discharge monitoring solution. This is a permanent monitoring solution for partial discharge. It can perform pre-diagnostic analysis, and it will send you alarms. So it will tell you if there is something before you even open it. The technologies are electromagnetic sensor. There is no galvanic connection. The PD measurement have the pattern, the waveform, as well as the frequency spectrum. It can do the communication through the fiber optic or the cellular solution as well. Performance is very high sensitivity with a ultra wide bandwidth up to 100 megahertz. It can go up to 9 channels. Very easy to install, and you don't need a downtime to install this for information. One of the other culprits that operators cannot take care or see very much is the screen current or the sheath current. Basically, if you have imbalance in the sheath current, that can cause issues in your system and failures eventually. And this is not due to the quality or something, mainly due to the installation that happened before. So with this solution, we can verify that the cable is not thermally stressed beyond its nominal limits, and it will allow you also to verify the healthiness of your SVL. Now, the technology is analog digital input-output. You can use the other many different type of sensors, like the RTDs, thermocouples, Rogowski coil, any kind of sensor from 4 to 20 milliamperes. For example, the pressure sensors. And plus, you will have an algorithm to tell you what's going on. So it will do the pre-diagnosis as well for you. Imagine you have thousands of thermometers on your cable to monitor its temperature, to understand what's going on your cable. Basically, your cable, as you've seen here in this picture, it's damaged by the hotspot. There is overheating at this specific location due to the bad installation. Something happened to the installation. This you cannot detect easily. So you need this kind of solution, which is the distributed temperature sensing, to identify these hotspots and try to fix them. Also, it will allow you to safely maximize the utilization of your circuit, even during emergency loading. The technology, there are 2 technologies, Raman, Bril 1. The difference is the range. So Bril 1 is the longer range, Raman is the shorter range. It can go up to 160 kilometers of range to monitor all your cables. So subsea, underground, everything can be monitored here. One of the other issues that operators face is the excavation happening or damaging your cable through the, we call it third-party intrusion. So these, for example, some contractors, they go and they excavate and they damage your cable. Suddenly you receive a request to go and fix. So you are running to failure. You are not preventing it. So basically, the solution, the DAS, the distributed acoustic sensing, will allow you to detect the third-party intrusion, as well identify the location. If there is a cable fault happening, it will pinpoint that location. The technology is coherent relay signal. Performance is up to 70 kilometer, localization up to 10 meters. The channels are 2. Now, since we are having this data-driven trend, basically all of the information, all the solutions that I've explained are all gathered in one platform, okay? This is an integrated monitoring platform. It will allow you to see what's going on, and it will help you also to go to the extent to identify the health index of your system. And it will give you alarms and so on. So basically, it will have a partial discharge monitoring, temperature and opacity monitoring, pressure monitoring, as well as the identification of third-party intrusion through the DAS, or the temperature of your cable to improve your installation condition. Another benefit of this platform that it has trending. Basically, trending is, for example, for the partial discharge, it's a rule of thumb. If you have an increasing amplitude, that is a really good indication of the partial discharge, and that's a critical partial discharge, and you have to take action immediately. Also, it has trending in the sheath current trending, as well as the local cable temperature trending. Success case from the field. This is a 400 220 kV step-down transformer, power transformer. As you can see, the customer has been using the portable device to take measurement as a condition-based monitoring. And they found out that this R phase and the Y phase, they don't have any kind of anomalies, whereas in the B phase, it shows a criticality in terms of partial discharge. And these type of partial discharge are internal partial discharge. You cannot see with your eyes. So when they opened, because it's a very critical asset, this is what they found, okay? Now, you may say it's a termination, and it might not, okay, if it fails, nothing will happen, okay, you can replace it. The problem with the termination on a 400 kV transformer, it can lead to a catastrophe. Catastrophe in terms of loss of money, loss of power, loss of many things. So this is something that an operator would not love to have. As a summary of the main benefits of the online monitoring solution, the partial discharge, it has a high performance bandwidth. It is a portable solution, very fast, safe for the operator. The data management are easy. Everything is available there in the integrated platform. Complete PD measurement can be done very quickly, because I noticed in the previous presentation, they mentioned that they took too much to take the measurement. This is a 2-minute measurement. Can you imagine? Also, it will reduce your operation cost by going from the preventive maintenance up to condition-based maintenance, and the last stage will be predictive maintenance. It will allow you also to monitor critical asset easily. For the distributed temperature sensing, it will give you the health of your cable from the temperature perspective, as well it will identify the hot spots. So you can modify the installation rather waiting, because these hot spots will degrade your cable and it will reduce its lifespan from, let's say, 30 years, 40 years, up to 10 or less, yeah? It will also allow you to load the cables to the maximum during utilization. Now, as a general benefits, monitoring system, it will, everything can be monitored in one platform. You will have the trend, and you can have our 24/7 support from our control center with our expert, giving you also the interpretation of the data you are having. You have also local technical support. All our products are IP68 ready. Thank you very much.
Thank you, Mohammed. Thank you, Mahdi. What really stands out today and yesterday is that the electricity market is really evolving and transforming. Now, Oman Cable is not only selling that piece of copper, that copper or aluminum, now they are selling the experience. Thank you, Mohammed, and thank you, Mahdi. Next speaker, I'm pleased to welcome Dr. Hisham Badahdah, Senior Engineer and Project Manager at GCC Lab. Dr. Hisham earned his PhD in Electrical Engineering from Marquette University in the United States. He currently manages major project of Aramco, focusing on electric machines design and power systems. Today, he will share his insights on enhancing strategic decision-making in power systems using the analytic hierarchy process. Please join me in welcoming Dr. Hisham to the stage.
Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you everyone for attending today. Which one is it? Okay. So today I'm going to talk about enhancing strategic decision-making power system using a tool called AHP. So why did I choose this topic? Because many of us started as electrical engineers, studying electrical details during university or college, and then at early stage, you start as also electrical engineer, go in details with the technical issues in daily basis. However, when you move into management role, this technical knowledge is not enough alone. You need some new skills and tools to guide you during decision making. So as executives or managers in the power or energy sector, we always face multiple priorities, okay? So when it's starting a new, whether to start a new business or venture, expanding operation, hiring talents, or decision which technology to adopt, or any other strategic options. So decision-making in the power and energy industry is becoming increasingly critical. As a leader, face growing complexity, numerous variables, and competing priorities. So I think we do need a structured approach to reduce ambiguity and also make balancing choices. So to address this complex decision, decision making often in a daily basis relies on intuition, okay, or historical practices or isolated KPIs. So this is for the daily basis problems or issues. But when we move to a complex problems, this intuition or historical practices would be failed. So we need something to help us to solve this issue. So as approach, I decided to choose this method, which is called AHP. This process, because it's one of the easiest, not easy, but one, it's an efficient and easy to use or to implement in our offices. We can use multi-criteria decision-making methods. And this method developed by someone called Thomas Saati. So in these problems, so we find the problems and divided them to sub-problems, and then ensure this method will ensure our decisions are logical and consistent in decisions. Okay. So the steps of using this method: first, we start with defining the goal, and then define the criteria and sub-criteria, and then list the alternatives, pairwise comparison, and then calculate the weight and aggregate the result. So this is the steps. We will go one by one, and we will we'll get an example. So, for example, we will have this issue. For example, we want to decide which strategic option to prioritize this year. Okay. So we do have, for example, these 4 alternatives: A1, A2, A3, A4. New area of business, expand the scope of current business, or implement a project X or Y or Z, or launch new initiatives. So, for example, we do have this issue, and we want to solve it. Then we will choose the criteria for decisions. For example, for these previous 4 alternatives, we choose these 4 criteria. First is the financial impact, and we call it C1, time to implement; C2, strategic alignment; and C3. Again, to summarize, the goal is prioritize strategic options, criteria C1, C2, C3, and the alternatives 1, 2, 4, and A4. Okay? So here, as you see, first is the goal, the second line is for the criteria, and the last line, A1, A2, A3, A4, is the alternatives. Okay, so here we start. So at your office, you bring your experts and sit together in a meeting room and start the game. So first, you take each criteria, C1, C2, C3, and make comparison between each one. For example, C1, okay, with C1 with C1, of course, it will be 1. And then C1 with C2, you, with your expert, decide to have them like 3. And for A1, C1 and C3, it's 5. You can weight them from 1 up to 9. And you do for the rest of these criteria. So you make comparison between these C1, C2, C3 with each one. And then you have to normalize your weights for reference, C1, C2, C3. And after we make the calculation, we find that C1 is 0.65, 0.23, 0.12 for C3. And if you count them, of course, it will be 1. And now, again, for A1, A2, A3, A4, also you make comparison between each one, but you consider one of the criteria. For example, here we take C1, the financial impact, and make comparison between each one, A1, A2, A1, A2, A1 with A2, A1 with A3, A1 with A4, okay? And you do the same for the rest of the alternatives. After that, also, you make weighting them, and you get this value. This value is only for the financial impact criteria. You will repeat this again with the remaining other criteria. So you will get, of course, because you do have three, so you'll have three different tables. And here you use this equation, the weight of criterion multiplied by each one of the alternatives. For example, here we take C1, okay, multiply by the weight of the A1 in the first category, and then 1, 2, 3 multiply by this one, and the last thing is you get the score of A1, which is 0.25 plus, and you get this value. And you see here the summary of the whole process. So this is the first line we saw in the previous slide. And then you do it again with A2, A3, A4. And it's clearly show that A2 for us is the best choice. So this is an example giving for this for using AHP. You can use this tools for any practice. For example, in power system, in technical manner, for example, you can use, for example, like Engineer Yusuf said, that we have 1,400, and out of this 1,400, we found that we do have, for example, 20 transformers needs to be replaced. But you have shortage in the budget. Which one you have to choose? So you can apply this for these 14s to prioritize them. So you can, for example, in the first year to replace the first four, and then the remaining in the years after. And you can make different criteria, for example, age, remaining life, load, importance, serving critical areas, for example, burial history, reliability, replacement, repair cost. All this you may consider them as criteria. So you have a wide choices in the alternatives, also wide choices of criteria. If you want to make it easy, you can minimize the alternative criteria. If you want to make it harder, you may add more and more. And also you can use some tools. I think there is a built-in at MATLAB, also Excel. You can use these tools directly. You just add the numbers and you can get the decision. So, also, as I mentioned, you can use this tools in border application, such as asset prioritization, investment decision, technology selection, or in other strategic planning. So to conclude, HB can be applied broadly across different in the energy sector, asset prioritization, investment planning, as I mentioned before, and also can help us to evaluate complex decisions. HB also provide transparency, rationality, and also consistency to decision-making processes. In era of increasing complexity, I think adopting structured method like AHP is a power tool to be used. Okay, that's for my presentation. Thank you.
Thank you, Dr. Hisham. Decision-making tools is at the forefront of any optimization initiatives in any organization. Thank you very much, really inspiring. And now to our final speaker, Mr. Waqqas Hussein, Business Development Manager at Machine and Fabric Greenhousing. Waqqas Hussein is a seasoned professional in the renewable energy sector, holding a master's degree in renewable energy management from the University of Freiburg, Germany, 2012. He is also a DOA certified senior solar PV expert, 2018. Currently, he serves as the business development manager at Machine and Fabric Greenhousing, specializing in distribution grid and solar PV applications. With over a decade of international and interdisciplinary experience, Waqqas is dedicated to driving innovative solutions for energy transition across the Middle East, India, and Africa. He will share insights on optimizing large-scale PV plants using OLTC and power quality solutions, a crucial piece of the energy transition puzzle. Welcome, Mr. Waqqas.
Assalamu alaikum and good morning. Thank you very much for coming here. My name is Waqqas and I work with MR. Every new renewable generation plant to be connected to the grid must fulfill minimum technical requirements to ensure the safety, reliability, and the quality of the power network it is connected to. This is why we have grid codes which cover extreme scenarios of active and reactive power, voltage and frequency, power quality, control capability, fault behavior, and protections, among others. Oman Grid Connection Code is like no other. Any solar or wind farm to be connected to the network must fulfill these requirements. Most important for inverter sizing are voltage and active and reactive power capability. In Oman, any solar wind farm to be connected, it must be able to provide a reactive power of 0.33 per unit when the active power is between 20 to 100% of the nominal, or alternatively 0.95 lead to lag depending on the control requirement. This reactive power must be provided within a voltage variation of plus minus 10%. On the other hand, the capability of a solar inverter, it varies at different voltages. When operating at 0.9 per unit of voltage, the inverter gives 10% less power output, but when it's operating at over voltage, its DC operating range is reduced. To overcome this challenge, the engineers have three options: either to oversize inverter capacity, add extra number of inverters, use additional compensation equipment to provide additional reactive power, or overcome this challenge in a more efficient and economic way by using on-load tap changes in the transformers, which I'm going to talk about today. My name is Waqqas and I work with MR. We are world market leader in voltage regulation technology. Today, from our portfolio of load flow and power quality, I will talk about only three topics: voltage regulation at inverter station, on-load tap changes for the main power transformer for the interconnection, and power quality solutions to cover any issues beyond the steady state conditions. But first, why regulate voltage at inverter station? We know that the inverter capability varies with the change in voltage. And here I have Some example layouts of PV arrays with string or central inverters using 2-winding or 3-winding transformers. The inverters must fulfill the steady state conditions of plus minus 10%, which they are certified for. But depending on the plant conditions and the grid situation, at the inverter level, they face voltage fluctuations throughout the day, which impacts their capability. If we add an on-load tap changer to the inverter station transformer, we can supply the inverter with a fixed voltage, even in overexcited and underexcited conditions. The analogy of a transformer with an on-load tap changer is that of a bicycle with gears. The tap changer allows it to change the winding ratio of the transformer during operation and regulate voltage on the LV side of the transformer. The heart of such a transformer is our most compact vacuum-type on-load tap changer we call EcoTap VPD, which is setting a new standard in distribution network planning worldwide. It sits inside the transformer tank and fits on top of it, connected to a control unit for easy parameterization and AVR capabilities that can be extended to connect with SCADA. The result is a transformer which very much looks like a standard transformer, but it has voltage control capabilities. When using in a PV plant, it means that the inverter, instead of plus minus 10% voltage variation, will have now stable voltage, only plus minus 2%. So you can design the plant with up to 8 to 10% less inverters. Additionally, the voltage can be dynamically adjusted during operation. At peak production time, by raising the voltage, the inverter capability is increased and the generation is increased. On the other hand, at the start of the day, end of the day, in low voltage DC situations, by lowering the voltage, DC and PP losses can be reduced. This control strategy was studied by Technical University of Braunschweig in a 105 MVA plant in Texas, USA, to quantify the effects of on-load tap changes on the annual yield of a solar PV farm. A plant with 1.25 DC-AC ratio and central inverters was simulated with the silent power factory with or without OLTC under different reactive power scenarios to give the results. On the right-hand side, you can see that the use of tap changer around midday, it reduces the clipping losses to almost half. And around the end of the day, the low DC losses are reduced by lowering the voltage. The result of the study, up to 3.5% increase in annual yield, which is equivalent to around 10 gigawatt hour in this specific case study, and less than 2 years of payback for the additional OLTC cost. Secondly, the on-load tap changes for main power transformer are quite a norm and often specified by grid operators to have it mandatory to decouple the plant from the grid, where vacuum-type OLTCs are used and delivered from us all over the world. But how can we make power transformers more sustainable, efficient, and reliable? Today, I would like to highlight the evolution of a vacuum technology in the form of VacuTap VI. We have introduced a new integrated type on-load tap changer for power transformers up to 100 MVA, which does not require a separate tank. It fits in the main shared oil supply. It has an innovative DC direct drive and an automated regulation. What is its impact on the transformer as a whole? Let's have a look. No OLTC oil compartment, no piping to the oil conservator required, a smaller oil conservator, no OLTC oil level indicator needed, no separate dehydrating breather, and no OLTC protective relay required. no drive shaft, a smaller transformer tank, and overall 30% smaller transformer size for the same power output, saving up to 350 kilograms of steel and 1,000 liters of insulating liquid. And its overall impact on the CO2 emissions for the lifetime of the transformer, less than 25% than our conventional vacuum type OLTC. In terms of size, we're talking about 13% smaller tap changer compared to a conventional vacuum, and it is similar in size to an oil tap changer, which makes it ideal for retrofitting old oil tap tap changers to upgrade them with vacuum OLTC. Thirdly, another important aspect for grid compliance and optimization is power quality. And this includes harmonics, flickers, rapid voltage changes, and so on. In power quality, we overcome these challenges by using static solutions, which are capacitor-based, like power factor control and harmonic filtering, MSDCN, or dynamic power quality solutions, which are power electronic-based for very rapid response between 10 to 40 milliseconds, like StatComs. I will share with you a case study from Australia on a 99 MVA solar farm, where a harmonic study was conducted by our team to ensure grid compliance. Without the compensation equipment, the study shows harmonic distortion at the point of interconnection, especially resonance at 13th order and a chance of amplification at higher orders beyond 25th. By using harmonic filters at 33 kV, the distortion limits are reduced and the resonance is avoided. Before I conclude, I just want to share a quick overview of some selected references. In renewables, such OLTC and power quality solutions are used in all types of renewable generation plants all over the world, let it be solar, wind, or hydrogen projects to optimize the rectifier transformer. To conclude, 3 key aspects how we can optimize large-scale PV plants. By regulating voltage at the inverter transformer, we can enhance inverter capability and lower plant costs, increase yield. By using only tap changes in the main power transformer for standard grid compliance, that can be made more efficient by using integrated OLTC design. And thirdly, static and dynamic power quality solutions to ensure optimal performance of the plant throughout its lifetime. Thank you very much for your attention.
Perfect closing talk. Thank you, Waqas. The topic that ties everything, innovation, renewables, stability, so it's really impressive. Now I think we're moving into our panel discussion and Q&A session. Thank you all to our speakers for such insightful and thought-provoking presentations. Now I would like to invite the speakers to take their seats on the stage. And while everything is set up, so I think they will sit in order. So once everybody is seated, just I would like to invite everybody to ask questions. We need more interaction from the audience. And please remember that we don't charge for questions, so please ask. Ladies, gentlemen, everything is yours now. Please raise your hands. approach the microphone and drop your question. Because I don't like to ask questions to the panelists, because people thought that it is already prepared before the session.
Assalamu alaikum. This is Mohammed Al-Busaidi from OGC. I would like to thank everyone, the moderator and the presenters for this session. I just have a question for Engineer Yusuf Al-Hadi. In your presentation regarding the health index of the model that you have developed for the health index of the transformers, I saw that you included a weight for every parameters. So I was just wondering how those weights were determined based on which criteria? Shukran.
Thanks for the question. As I mentioned before, we have taken 3 frameworks. One, the model of the Norwegian model, and the second one, engineering experience and historical data. The third one is international data. So the model of the Norwegian has its own parameters and equations. So we took that one and customized it to fit our model. So the weightage, we consider it based on our historical and, let us say, fits our environment at NEDC. So I will give you, for example, that how accuracy of our model, since we have changed some of the weightage and the scoring from the Norwegian model. We have compared it with 2 models, one from UK and the other one from Saudi Arabia, 2 models. And the accuracy shown 98%, the 2% different because of the environment of the NEDC. So only we have played slightly with the scoring and the weightage for each category, for each gases, based on our historical data and engineering experience.
Thank you. Yusuf.
Assalamu alaikum. My name is Yusuf Mahrouqi from Lama Distribution Company. My question is to Waqas regarding the distribution on-load tap changer, which is not common here. And I know that the impact is because of the penetration of renewables, and also the impact maybe of EV cars that will have positive and high voltage in the morning and low voltage maybe at the evening time. When I saw the second presentation for the power transformers, you said that it can retrofit the existing one. But the difficulty is that for the distribution transformer, which is thousands of thousands, unless it's possible to retrofit on the existing, then again, I think it's very difficult to mount it on or replace the entire transformer. So is the solution be able to retrofit the on-load tap changer for the distribution transformer or no? Because I don't think that was clear from the presentation.
Thank you very much for your question. So for the retrofitting, the relevant on-load tap changer is the one for the power transformer. We're talking about vacuum tap VI. Before retrofitting, our team can, look at the transformer, investigate whether it's still efficient to retrofit and check the transformer conditions to ensure that it will be sufficient. But of course, it can also be used for new transformers. To add a comment about the distribution transformer, the distribution OLTC, these are typically, so I understand that your question is mostly towards the power transformer, vacuum tap VI, but just to differentiate, the distribution OLTC EcoTap VPD is not designed for retrofitting. So in that case, typically you don't have an OLTC, so you have off-circuit tap changer, which have less number of windings. And the OLTC in this case have, as a standard, 9 positions and optional 17 positions. In that case, we recommend only replacing the whole transformer with the new tap changer. You're right that in this region, it's not yet used very much by the distribution grid operators, but the demand is rising worldwide. And overall, for distribution, we have delivered more than 20,000 units in more than 100 countries that use different applications to increase the hosting capacity of the distribution network, to integrate rooftop solar, EV chargers, or to achieve energy efficiency measures, to stabilize for industrial customers, and so on. So if there are any questions or any specific transformers that you would like to have a look, our team is available at the event, and we will be really glad to answer further questions. Thank you.
Okay, that is clear. I think you have also a chance with number of local manufacturing companies for the transformer that you need also to speak with. I know you have a tie-up with them for the power transformer, but the distribution transformer maybe is like an option which we need to look at it.
Sure. So every transformer manufacturer, we work and we supply to every transformer manufacturer. And we actively train them when there is a new product, of course, as well as the end user to bring them on board. We provide all the necessary training and support to make sure that any new product is used in the proper way.
Okay, thank you.
Sure, thank you.
My second question is to Mehdi, and particularly to Oman Cables. Okay, installing sensors in the areas where you can see the asset is easy. But I have just maybe like taken the note that one of the sensors that said that can work and detect up to 160 kilometers. So can it be done can it give you any indications of, I'm not really sure if it's partial discharge or degradation on the insulation itself for the terminal, the joints, which is one of the weakest points that we have. We normally bury it in the ground, and then things never seen unless it's just flashed over.
Thank you very much for your question. Actually, I forgot to mention that the sensor is only the fiber optic that you lay beside the cable. So basically, the fiber optic you use for telecommunication can be transformed as a sensor and can measure the temperature of your cable, including your accessories. So you will know where are the weak spots in terms of temperature. What happens in reality? Okay. You install a cable, and somehow there are some locations where the installation conditions are extreme. So you go up to a depth of 7 meters, there is an intersection with other circuits. These kind of installation conditions can raise the temperature. And this is like a ticking bomb, basically. The cable is being degraded, and you cannot see that. So with the sensor or the fiber optic laid next to it, you can monitor that temperature, you can measure that temperature, as well as know the limited ampacity that the cable can take with that installation condition. So for example, assume, just give for assumption's sake, your circuit is allowing you to carry 700 ampere. But because of this installation condition that you cannot control, okay, the circuit is derated and can only carry 600 amperes. So in this case, you have a better visualization on your circuit, and you can take better decision in your load utilization. So you can either reduce the load or introduce a new circuit to withstand the new loading you are having in the area. I hope I answered your question.
You have the mic.
This is installed in the primary substation, isn't it? So you have the fiber optics, which is laid beside the cables, and then you can do this sensor and collect the information from the FOC cables, isn't it? So
Exactly.
we might have a discussion later on to check how this can be done.
Sure.
There is also one technique which I think I have heard from the cable manufacturer, but never introduced, where they have a hybrid cable, where you have the cables included the fiber optics in the same shield.
Okay, basically the hybrid cable with the fiber optics are mainly used for the interconnection, subsea applications, okay? That is the main use for them, and that's why the sensors are inside. But in reality, in underground cable, I think it's more economical to use the outside fiber optic. It's easy to install and easy to track if you have any failures in the future, you know?
Thank you. Okay. Thank you.
السلام عليكم عبد الله الوهيبي من IEEE. مهندس شنونة. Did you work out with in the energy efficiency program with the DSM, the demand side management? And is there any implication or conclusions you have found if implementing the DSM here in Oman?
Thank you for your question. So far, we have started implementing and certifying OQ assets first as a first plan. Then we're planning to expand our support to assets beyond OQ. So ISO 50001, as I mentioned, can be applicable in any sector in Oman or in the world because it's flexible, and I believe, yes, it can be implemented in the organization that you have mentioned.
So the last question from me. So we have only 5 minutes. So just I will ask Dr. Hisham, regarding any decision-making tools, what are the success factors? So I mean to make it successful and just to trust the decision made, because you know the decisions, the investments are based on decision-making tools. So how can we verify it and we make it really trusted?
Thank you for the question. Actually, I think, yes, you can trust these tools. And if you don't, if you want to check if your result is accurate, you can compare it with another tool. There is a tool called AMB, which is more complex. Another tool called also TOPSIS. So if you use multiple of these tools and compare between them, you will find there is a close result that found after you make the decision. I think these tools also sometimes involved in this monitoring system these days. So actually, it's already applicable in the modeling system.
Yeah, interesting. Thank you, Doctor. So I think we are closing now. So as we come to the end of this engaging session, a few reflections stands out. We have seen today how data, digitalization, and disciplined asset management are reshaping the way utilities plan and operate. From decision models and health index to real-time monitoring, renewables, and efficiency frameworks, it's clear that optimization is not a one-time effort, but a continuous journey. On behalf of IEEE and the organizing committee, I would like to thank all our speakers for sharing their valuable insights. And thank you, the audience, for your attention and participation. So enjoy the rest of IEEE PowerTalks 2025, and I wish you all the productive and electrifying day ahead. Assalamu alaikum wa barakatuh. So I invite Yusuf and Abdullah, that's okay.
Thank you, guys. We will resume the next session at 11. Please be back on time. And there is an announcement. Someone forgot his phone at the registration desk yesterday. If anyone is missing a phone, please get back to Anam at the registration desk. Thank you. Hi, everyone. Please be seated. We're about to start our session. It's about energy, conservation, and efficiency, chaired by Sadiqa Lawati, Advisor Business Development from OQ. Please, Sadiqa, come to the stage.
Assalamu alaikum, everybody. Good morning. I'm Sadiqa Lawati, Advisor Business Development at OQ Alternative Energy. And in addition to my role, I'm a certified energy manager and a firm believer in the important role energy efficiency and conservation has for Oman's decarbonization targets and economic prosperity. It's my privilege today to moderate session number 5, Energy Conservation and Efficiency, here at IEEE PowerTalks. Thank you for being with us. This session sits at the heart of Oman's pathway to net zero, where we cut emissions, improve energy management, and embed sustainable practices across industries. As we heard yesterday in the first panel discussion, the best energy we could have is the energy which we never use. Oman has already taken strides to improve energy efficiency of its grid. However, there's definitely much more we can do, which is what I am hoping we get out of the panel discussion today. I'm very excited for the session today, and I hope you are as well. Over the next 90 minutes, we'll move from national direction to industrial solutions to digital acceleration, showing how energy efficiency turns ambition into results. To help you today listen with purpose, let me offer 3 lenses at which we will look at our presentations today. 1, covering policy and institutions, 2, looking at technology and systems, and 3, looking at people, data, and finance. Every speaker will have a maximum of 15 minutes to present, and at the end, during the panel discussion, we will open the floor for questions, so please keep note of your questions. With that, let's begin. Please join me in welcoming Dr. Esma Al-Maqbali from the Oman Net Zero Center to present Oman's net zero initiatives in driving energy efficiency and conservation. Dr. Esma Al-Maqbali is Energy Efficiency Project Manager at the Oman Net Zero Center. She'll outline how national initiatives are driving conservation and efficiency across sectors, reducing carbon intensity, improving energy management, and scaling good practices. The floor is yours, Dr. Esma.
Can you show me how? Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everybody. It's both honor and responsibility to address you in behalf of Oman Net Zero Center. Our mission is clear: to lead Oman transition to sustainable and low-carbon future, to align our nation with the global objectives, and to achieve the net zero by 2050. Today, I'm going to speak about the Oman Net Zero Center starting point, initiatives, and the main pillar of Oman Net Zero Center. In 2022, His Majesty Sultan Haytham bin Tariq Al Said mandates the establishment of Oman
Sustainability Center, which is called today Oman Net Zero Center. And based on the ministerial mandates number 35/2024, 10 mandates were published to the public for what can be done through the Oman Net Zero Center. And these 10 mandates can be summarized in 4 main pillars. The most important pillar is about how we are promoting our scientific-based research roadmap of Oman, which is the strategic Oman Net Zero Center strategic, updated and pre-format. The second pillar was to monitoring that progress through all the industry sectors, from the industry perspectives, oil and gas, buildings, power, and management schemes toward that path. The third pillar was to develop the framework of the carbon market in Oman, and the fourth pillar was to accelerate the energy efficiency in building sector and industry sector. And this is through innovations and roadmap of building a local talent and innovation in the market. So the center is the engine room of the climate change in Oman. It's not only the climate, weather, and environment, rather than it's the path of net zero, and it is the technical enabler and the management strategic coordinator for Oman. As I said, one of the most important pillars of the Oman Net Zero Center, it is starting to update the Oman strategy toward net zero. And this strategy was established based on 3 phases. As you can see, the first phase was the baseline assessment, where the calculated of all gas emission in Oman and do the baseline for the emission of Oman. The second one was the decarbonization roadmap, where we have 3 paths. The first path was the business as usual, which is we are doing nothing for Oman to achieving that and keep the emissions of the carbon as it is as we go. The second path is the balanced path, and the third path was what if we are investing more in a harsh and a very strategic manner toward the net zero. However, we are choosing the balanced path, that it's balanced between the environment, social, and economic toward Oman net zero by 2050. To take that strategy to reality, we are applying to establishment the platform of Mizan, which is already interactive platform that it's not only a technical tool for Oman, rather than you can interact with it. You can see the real-time data analysis through that platform. Mizan, it's built based on 3 models. The first model was to see the emission in a real time. The second model is to interact. What if we are doing something related to the future, such as renewable energy or transition to the energy or any other things for perspectives? That gives a clear vision for the decision maker what if we are implementing these technologies to Oman. The third model is about the carbon credit registry in Oman, and it's not the cost, rather than it is an opportunities for the economy. The second pillar, as I said before, it is about the carbon credit market. The carbon credit are the cornerstone today for Oman and for the climate economy. The single credit is either to be a reduction or removable from the CO2 emission as a 1 metric equivalent from the atmosphere. These credits can be fall in 3 categories, as you can say. Either it is a reduction through a renewable energy, clean energy, or efficiency of energy buildings. The second thing is removable through applying the natural-based and the CCC Tentil solution. The third one is the avoidance, by avoiding the practicing of existing carbon stick from the environment. Actually, the carbon market framework, it's being established now within the environment of the Oman Net Zero Center, and we are trying to make it clear, achievable, credible, and all the organization can see how these credits can be transformed to the tradable market. And already Oman has unlocked over $50,000 for the credits that it's already removable from our environment. So it's not just a dream or it's a theoretical basis, rather than it is an economic value for Oman. The third pillar in Oman Net Zero Center, it is about energy efficiency, which is my specialist in that scope. And energy efficiency, it is when it's coming to the building, we are saying changing AC design, changing the lighting from the normal light to LED lights, or redesign the building and make it more sustainable design. It's going to be a lower operational cost, and as well as it's going to be reducing the emissions. For industry, it's going to be both. For the applying the management level for the process, and the second things for the building itself. And it's also going to be higher opportunity for them to reduce the energy, having less operational cost, as well reduction in CO2 emission. So it's a gain impact for all of us. The energy cost in Oman, it's making up to 35% of total of Oman energy. And by doing energy efficiency, we can minimize the gas emissions and protect that gas we are using in having the power to power these buildings and process, less consumer bill, as well as cost-effective and cost-saving for all Omanis and Oman economies. And it's less subsidies as well for the Oman. Moving forward, to make this happen with the reality with energy efficiency, there is a concept of what we call it as a super ISCO. So what is a super ISCO? It's a more structural way that we are structuring how these energy efficiency contracts is being managed. So the traditional way is through the ISCOs companies that it is in the market, but this is related to the more scattered, fragmented market, rather than having a one structural market that involving in a super ISCO. So we are, as Oman Net Zero Center, we are performance as a super ISCO for the governmental buildings only in Oman, and there is another super ISCO for the private sector. There are two main ways how we are doing the contract for the energy performance in super ISCO scheme. And these are either to be a guaranteed saving model or a shared saving model. What is the difference between these two? If we are seeing the guaranteed saving model, that means the clients will pay the cost rather than the ISCO company going to be guaranteed the saving of the energy through that platform. The other things, the shared saving, the ISCO company going to be paid the cost, will be the capital, and so on. That's things, so they are sharing the investment both in the saving way. One example of that, the Oman Net Zero Center launched 14 buildings to be implemented as energy efficiency building in the governmental sector. The capital cost of that project was 1.8 million Omani Riyal, and the internal return investment was 16%, and the payback period was only 5 to 6 years. One of the most important things that in role of Oman Net Zero Center is the engagement with the social as well as building the capacity. So we are in a partnership with the Sultan Qaboos University to announce about a new training program to certified energy auditor in Oman and accounting for the first pool in Oman, having these professional practice and certified them through a very well-known organization worldwide. And the objectives is to have that pool ready for the market. And the number of the participants is 50 participants from the fresh graduate from all over the university and the job seeker in Oman. And the program structures in 3 phases. The first phase is about the foundational. It's take 2 weeks. Then practical engagement with the real buildings in Sultan Qaboos University. And the third one was to be certified with the association, American Association, which is related to the certification. This is not only the mission for the carbon credit or the carbon emission reduction in Oman, rather than we are building our economy and we are building our future in Oman, having the people ready to take the target toward the Oman Net Zero Center. Thank you for your listening.
Thank you, Dr. Asma, for this very insightful presentation on the mandate of the Oman Net Zero Center. Next on the list, we have Steve Lemoine, CEO and General Manager, Middle East at Dalkia EDF Group. For 17 years, Steve has worked at the intersection of energy efficiency, O&M, and district energy networks, from consolidating utilities across Eastern Europe to building Dalkia's digital offer in the Middle East and expanding district cooling. Today, he'll speak on seawater energy recovery for district cooling, a crucial lever in Gulf climates. Please join me in welcoming Dr. Steve on stage.
Good morning, everybody. My name is Steve Lemoine. I'm the CEO of Dalkia in Middle East. Dalkia, it's part of EDF, French state-owned company. So EDF is working for the electricity chain from production of electricity, distribution, and energy services. So Dalkia is the company focusing on energy services. I'm going to introduce you the company first. So I will have a small movie.
In the Middle East, energy is evolving, and Dalkia is at the center of this transformation. From electrification to decarbonization, we are enabling smarter, cleaner energy use for all. Since 1937, Dalkia has been designing energy services that make a difference, powered by EDF Group and built on over 80 years of expertise.
At Dalkia, we are more than just an energy services provider. We are a global partner with over 20,000 employees committed to deliver tailored, innovative, energy-efficient solutions worldwide.
From high-performance digital platforms to on-site expertise, Dalkia offers solutions that reduce consumption, cut emissions, and extend asset value.
At Dalkia in the Middle East, we help our clients to achieve their sustainability goals. Whether it's through optimizing energy use, offering innovative, digitalized and advanced operation and maintenance services, or decarbonizing their infrastructure. With its dedicated local team in the Middle East, Dalkia is committed to support its clients to reach their net zero target.
Across the Gulf, our teams deliver energy solutions tailored to the needs of commercial, healthcare, and industrial clients. Safety and expertise are at the heart of our operations. With 450 dedicated professionals in the region, our mission is people first, every time. Together, we power the transition.
So of course, the topic mentioned just before about energy efficiency ring the bell for me, because Dalkia is one of the leaders in implementing energy efficiency measures. I'm not here to speak about energy efficiency, I'm here to speak about the seawater cooling. This is the activity provided by Dalkia globally, actually. The company has been created more than 80 years ago. We are about 23,000 employees worldwide, and we have started our activity in the Middle East in 2018. So we do district cooling projects. We are a developer, so we invest in district cooling project. We build district cooling project, and we operate district cooling project. It's one of our main pillars. We do as well operation and maintenance of chillers. Chillers is really important, especially in this region, because it's, of course, very warm, so you need to cool, all these equipments. So we have a strong expertise in chiller, replacing equipments, retrofitting, retro-commissioning. We do as well asset efficiency and lighting, street lighting projects. So we have a strong experience with this kind of activities. We are managing the street lights, for example, in Paris. We signed recently a project in San Antonio in the US, and we are working also in UAE, in Al Ain, where we are going to do operation and maintenance of street lights equipments. So asset efficiency is also very important. We have what we call in Dalkia the Dalkia Energy Services Center. It's an IT tool, an AI tool, where we monitor the performance of buildings directly from our office. So it's quite efficient. We do as well solar installation and operation and maintenance. You saw in the video, some of our references. We develop now more CNI projects. We did about 50, 60 megawatt in the region about CNI projects. And we do as well this activity on data center. We operated about 80 data center worldwide. So we support the operator of data center to design the energy equipments and maintain them. It's quite important for a data center to be sure that they will receive all the time the right amount and quantity of cooling. So now I will focus more on district cooling systems. Dalkia is operated about 330 district energy networks in the world. So we are one of the biggest company operating district energy networks. And you have three main points to optimize this kind of systems. The first one is the technology and the design. Of course, you need to select the right chillers, you need to select the right cooling system, and so on, which is important because it will give you a better efficiency. And you need as well to size properly. So the design component is quite important because depending on the need, you need to design properly your pipes and of course your plant. Operation performance is key. I said that Dalkia has been created 80 years ago. We are an operation and maintenance company. The first client we signed 80 years ago, it's still a client of Dalkia today. So we really value the operation and maintenance activity, and we are here speaking about the way you will be using your different equipments on site, like energy storage systems, also the system control philosophy, which is quite important for us, and the maintenance. Building is also important. I mentioned the energy efficiency just before. We are really taking care of our clients and the demand side. You all know maybe the delta T syndrome, which is something we take care of in order to make sure that the plant will operate properly. And the last part, this is the free energy use. You have the natural energy, which is solar energy recovery. I presented some slides before. Geothermal energy recovery as well. So we are going to take within the earth some energy, and we are going to use it in our systems. I see, by the way, a big potential in Middle East regarding this technology, and we are working on few projects right now. Seawater energy recovery, I will focus, of course, more on that right now. And the human activities recovery, it can be air heat recovery as well as waste recovery. So for seawater, you have pros and cons. Of course, it's a proven technology. I will speak about that, but you have lots of references existing today in the world. It helps to conserve energy as well as water, because normally you have closed loop. I will go also into that. And it helps to save space on the building, because this kind of activities and this kind of technologies will not be present in the building, so you can optimize the use of your building without having so many technical equipments on the roof, for example, or in the basement. The cons on that are the upfront investment, because it's normally costly to do this kind of installation. Design and material selection, because of the corrosion with the seawater, you have to do some titanium, for example, equipments. So it's quite complicated on the design point of view. Environmental regulation is also challenging. We see that in Europe. We see that as well in countries like the Kingdom of Saudi Arabia, UAE, but Oman is exactly the same. So we are facing difficulties, you know, to convince and to speak with the Ministry of Environment or Energy. And the maintenance requirements, because it's specific and complicated to maintain this kind of equipment, going quite far away in the water. You can see it's not a new technology, it's proven, it's existing. It's mainly actually on islands. You can see it in Hawaii, for example, the French Polynesia. So you have lots of equipments like that where we are recovering energy thanks to the energy in the water. You have different technologies. I will just mention some of them. You have the one which is through a heat exchanger, and I will present you a case just after where you will see exactly how it's working. You have the seawater cooling chiller with direct condensation, and you have also the possibility to use cooling towers and to cool the cooling towers. You have few references, for example, in Bahrain, and you have what we call the thalassothermy, I like the word, which is temperature water loop with seawater energy recovery. And your objective of energy efficiency will be less or more depending on the technology you will be choosing. So this is one of our projects out of many. We have, for example, in Monaco, we are using the same technology to cool a casino. Here, it's a new quarter we have developed in Marseille. You have a first loop, which you can see on the bottom part. It's the seawater one, so the temperature is about 12 to 24 degrees. And after that, you have a heat exchanger and non-salted water with another loop, a second loop. And this second loop will go to an energy system where we will complement the temperature of the sea by a heat pump. It will help us to provide energy to the buildings. So we provide heating, we provide sanitary hot water, and we provide cooling. And Dalkia, as a service company, go further. As you can see on the full right, we work as well on exchange between buildings. So the need of energy for buildings is different from one day to another, or one part of the day to the rest of the day. For example, you need more cooling. During the day for offices, and you need more cooling during the evening or morning in residential buildings. So they will exchange energy as well. This kind of global system is exactly Dalkia, what we are doing in Dalkia. So I will present you, some pictures of the project we have. You can see on the first picture the plant and the network, which goes to the residential buildings. You see as well the heat exchanger. You can see as well all the works we did to implement this kind of project with a different construction phase. I see lots of potential in Oman because the water and the temperature in the water allow to do this kind of project. And we are working right now with few clients in order to develop, these kind of systems. And I think much more can be done. It will help us to save energy and to have decarbonized energy. And this energy, when it's done, it's absolutely free. You can use it as much as you want. So I have a small movie presenting the project we did in Marseille, in France.
Les grandes métropoles se doivent de réfléchir à des solutions nouvelles, intelligentes et évolutives, mais aussi solidaires. L'eau, source de vie. L'eau, source d'énergie.
Le réseau Massileo est composé de 3 parties. Une partie valorisation de l'eau de mer, une partie boucle tempérée et une partie production de chaud et de froid pour alimenter les bâtiments. Sur la première partie, nous pompons de l'eau de mer à 4 mètres de profondeur dans le port de Marseille. L'eau passe dans un échangeur et est immédiatement réinjectée dans la mer Méditerranée sans perturber l'écosystème. Les calories prélevées dans l'échangeur permettent de réchauffer une boucle d'eau tempérée. Cette boucle d'eau tempérée elle-même va alimenter un local de production composé de plusieurs pompes à chaleur qui vont réchauffer l'eau pour faire du chauffage ou de l'eau chaude ou refroidir l'eau pour faire de la climatisation. Avec Massileo, nous avons réussi à concilier innovation technique, valorisation d'énergies renouvelables locales et compétitivité du prix des énergies fournies aux utilisateurs. Ce projet est exemplaire et il est duplicable et il permettra d'accompagner la transition énergétique sur l'arc méditerranéen, mais aussi sur le reste du territoire français.
Acteur clé de la transition énergétique, EDF imagine et réalise aujourd'hui les réseaux énergétiques de demain.
So this is one of the solutions the group Dalkia and the group EDF can propose. So my presentation is finished. Thank you for your attention, and we are welcoming you on our booth where you can speak with the people from EDF and Dalkia and where we can present more about what we do and what we can do, of course, in Oman to support the decarbonization plan. Thank you very much for your attention.
Thank you, Steve. Next, please join me in welcoming Alan Freeman, my colleague from OQ and Head of Energy Services at OQ Alternative Energy. Alan is responsible for delivering OQ's decarbonization targets with a strong emphasis on energy efficiency, bringing experience from Innova by Veolia on energy performance contracts, ISO 2001 implementations, and renewables across the MENA region. He's a chartered energy manager and CMVP. Alan will share OQ's efficiency ambitions and the potential of a super ESCO approach to unlock project portfolios in Oman. The floor is yours, Alan.
Thank you, Sadiqa. Assalamu alaikum to everybody here. So my name is Alan Freeman. I'm representing OQ Alternative Energy today. As Sadiqa said, I'm part of the Energy Excellence team, and today I will take you through a presentation explaining, I suppose, the concept, the scope, the life cycle, and the financing of energy performance contracts. You've probably seen or some of you may have seen or may not have seen the announcement yesterday from OQ that we signed the energy performance contract in the region. I will also mention the Super ESCO approach, as Dr. Asma mentioned, for Oman Net Zero Center, that we're implementing a very similar approach for this project. So just a little bit about OQAE first of all, so I'll only take 1 minute on this. So OQAE was established in 2020 with the focus on 4 main areas. One was portfolio development, so you will see many solar, wind, renewable, hydrogen projects being announced. We also have a development portfolio for energy efficiency that we can mention today, but we will just concentrate on one main project that we have moved. Also, we lead the OQ decarbonization roadmap and projects to be implemented. We're also looking outside of OQ at the moment to support other Omani companies and government agencies to achieve their targets. Diversification away from the traditional oil and gas economy of Oman, so we're looking at that and how we can drive that from OQAE point of view. And also capacity building, which is a vitally important part, also mentioned in Oman Net Zero Center, so we need to examine and train and teach the next Omani leaders to be able to, in a position to look at the energy transition going forward. So when we look at energy efficiency, it's been mentioned many times over the last 2 days I've seen. So we all know the main drivers of energy efficiency, a study that was conducted a few years ago, so there is huge potential. 12% reduction in industrial energy emissions can be achieved through energy efficiency measures. And in the non-industrial sector, 22% can be saved. So really, this is a huge number that is relatively untouched, I would say, so far. So the four main pillars, or the 4 main benefits of energy efficiency, is the reduction in the bill, so monetary savings, cost savings, gas monetization, which is one that's been mentioned a little bit as well, but it's really important for Oman, because when you're looking at the electricity system, which is subsidized, the free up of gas that you can achieve from energy efficiency measures can turn out to be a major plus for Oman and can impact your GDP in the long term. And also, as we said, it's a given CO2 reductions and emissions reductions. So in terms of energy performance contracts, so when you're doing a performance contract, we rely on ESCO companies, so it's energy services companies. Dalkia is one that we just seen a few minutes ago. So the key concept here is that you're implementing a range of energy saving measures in one project. I will touch more on that in the next slide. The savings have to be measured and verified, so there's a certified measurement and verification plan that has to be submitted with these projects. The investment, in the most part, is repaid by the savings achieved. So whatever investment is put up front, the annual savings achieved over the course of the contract pays for the CapEx and the OpEx. And the risk, the technical risk, lies with the ESCO company. So all of the risk that you may have in your plant can be transferred to the ESCO company, and the financial risk can be taken by the investor, or what we call a super ESCO company in the middle. We all know about the cost savings, but some other additional benefits from this type of a contract. So you have improved reliability and comfort. So the KPIs that you have in your plant can be transferred to the ESCO company, and they are responsible for reliability, for the response times, for the performance of the assets. So it's mostly around the HVAC systems, maybe pumps, chillers, etc. We will go through that. Long-term results that are guaranteed. So in these contracts, you have a performance bond. So if you don't achieve your savings, you have the right to cash that bond. So even from that point of view, you are de-risked. FM and maintenance costs as well is something that's not always considered. So as part of these deals, the ESCO company has to maintain this equipment for 6 years or 8 years or 10 years, whatever the duration of the contract. So therefore, this cost that you have on your books at the moment as an end user, this can be transferred as well. So it's an additional cost saving that you won't have to invest as an OpEx or even as an avoided CapEx from the next 5 to 10 years. So the scope of energy performance contracts, so this is generally for the project we announced yesterday, but this can also be implemented across the industrial sector in a project point of view, looking at steam systems, hot water systems, compressed air systems. This can be replicated across that industry, but this is focused on the building scope that we have in OQ. So our project will look at the HVAC and chillers. We will upgrade some chillers. We will put in fresh controls. We will also control the HVAC system downstream of that through building control sensors, temperature sensors, scheduling, etc. We will upgrade some pumps, motors, and drives as well to improve the efficiency, including VFDs where they're not there presently at the moment. Lighting is a great one for the payback it delivers. So we have, I think, 23 or 24,000 lights that we will upgrade. So this payback from this ECM makes other ECMs workable from a payback point of view. Water is also often forgotten about. So we have seen many sites where there is water being wasted through inefficient irrigation systems or leaks in the pipe network or something that is going missed. Also, in our scope of works, we will include renewables as an optional ECM. So we would like to include car park or rooftop solar in our projects where feasible, if the payback is reasonable and if the payback fits into our criteria. Just go through this quite quickly. This is I suppose, the life cycle of energy performance contract. So above the dotted line is all the study period and detailed engineering phase. So you have to establish your baseline, which is generally your energy consumption, water consumption. You go through then typically 2 phases. One is kind of a filtering phase where you do a high level, maybe plus minus 10% results, where you invite maybe 4, 5, 6 ESCO companies to compete against each other. You award your preferred supplier at that point, and then you go to a detailed engineering phase, which can take 2 to 4 months, depending on the complexity of the project. It gets serious after the dotted line where you actually sign the contract. So a binding offer is submitted, fixed price, turnkey solution with the guarantee minimum savings to be achieved. Then you sign the contract and you head into the implementation period, which is 6 to 12 months in my experience. Then once that is completed, testing and commissioning is done, you go into operation and maintenance and also measurement and verification period. So operation and maintenance, I mentioned, the scope that would include in the ESCO will be transferred to them, and they will operate and maintain that equipment for the duration of the contract. Measurement and verification is a vital part of this contract as well. So any savings that they promise, they have to verify it. So every quarter we will receive a report to say you achieved X amount of savings against what the baseline was at the beginning of the contract. And then if there's a conflict, we have to adjust the baseline, or if there's a fault in savings, we have the bank bond in our back pocket as an investor. So this is the key difference, I would say, this operation maintenance M&V from your typical EPC works. The financing part of it, so we've mentioned Super ESCO in previous presentations. We've probably heard the word around a lot in the last couple of months and probably years, but essentially we tried to break it down into this, and this is particularly for our project up in RPI. So you have 3 main stakeholders, you would say. So you have on the bottom right, you have the client. In our case, it's OQRPI. So they will receive new assets and services from the ESCO company. And then what savings are achieved through the project, this is reinvested back into the investment company, which in this case is OQ Alternative Energy. On the other side, you have the contractor. So this contractor will get paid its CapEx for supplying the equipment, and they will get paid the OpEx for operating and maintaining that equipment through the duration of the contract. In return, we will receive a savings guarantee, and we build all our financial model on this savings guarantee. In this case, as I said, OQ Alternative Energy is the investor, or the Super ESCO type, is the Super ESCO in this type of a model. Where we get our money from, it depends. Sometimes it can be shareholder loan, sometimes it can be equity, sometimes investor. This is our problem. We have to figure this out. But in general, tried to simplify it down to this. Obviously, we're going into implementation for one project. We have a second one almost ready to launch to the market, but we're also, as we said at the beginning, we're a project development company for renewables, for energy efficiency. So we can replicate this model across other maybe industrial sectors or other buildings outside of the governmental buildings, as Oman at Zero Center, Dr. Asma mentioned earlier. So almost finished, so there's just 2 more slides. So this is our project in OQ RPI. So in scope, we have 150 buildings. It's in the SOAR industrial area. The buildings are made up of a few admin offices, which are big energy users, occupied a normal working week. Then you have other office areas, you have substations that we have to maintain to a certain temperature. We have laboratories, obviously, as well, that have specific air change rates and temperature controls. And then you have control buildings that are occupied 24/7 because it's inside the refinery area. So these are many different types of buildings that we had to look at, and we have different solutions to be implemented on each of the buildings. For example, in the office areas or admin areas, normally on a weekday, offices are normally empty from 4 p.m. onwards, 5 p.m. onwards. So we look at different options there for cutting back the HVAC, cutting back the chilled water supply at that time. Whereas in the labs, we have to be more cognizant of what environment we need to maintain. So anyway, in summary, the project will deliver 28% savings from the building baseline, which is quite good. The equivalent of 22.5 gigawatt hours, again, which is, from my experience, it's quite a sizable project. It's not small by no means. It will deliver CO2 emissions of 9,400 megatons per year. So this is annually. The duration of the contract is 6 years with the contractor, so we will hit significant CO2 reduction figures. And then if you convert it to monetary savings, it's about 1.2 million annually. So again, it's a nice number, it's a good number, and hopefully will prove the concept and pave the way for many future projects like this. The ECMs, as we mentioned, the energy conservation measures, they mostly around the HVAC system, so we're looking at the chillers, upgrade controls, adiabatic cooling, different measures like that. Also on the AC and package units, we will have lighting upgrades and lighting controls, and also a software solution where we can use AI to monitor and control these buildings in real time, basically, so we can improve the performance even further. And finally, we have a second project which is ready to launch. So because this one has been successful to date, we have clubbed all of the other OQ buildings together. So logistically, it's quite spread out, but it includes all of the buildings included in OQ's portfolio. So you have gas network, base industries, EP, some more RPI buildings, which is logistics. And the sum total of it all combined together, we have to make it sizable to get the interest of the ESCO companies. Because if it's a small project, sometimes the interest might not be there. So we've clubbed it all together. It's a 50 gigawatt hour baseline. We are requiring that it is a 6-year payback maximum. We will launch it now. It's almost ready to go. It's with the tender committee. Locations are 110 buildings from Musandam right down to Salalah, Muscat obviously as well, and Faoud. We are targeting at least 25% savings. So what we will do, we will invite different companies and it will be a competition. So the idea is that we get maximum savings within the 6-year payback period that we require. And finally, it will be a 10-year contract, and we hope that the project is launched this year, awarded early next year, and then you will go into the implementation cycle, which is 6 to 12 months. So we anticipate Q1, Q2 2027 that we will be fully operational and we will be achieving savings for the remaining buildings. And I think that's it. So thank you very much for listening, and I'll take any questions later.
Thank you, Alan, for demonstrating a live example of how the ESCO model can be applied to Oman. Next in line, we have Professor Hussein Kadhim, the Chair in Emerging Renewable and Sustainable Energy Technologies at Sohar University. Professor Dr. Hussein holds a BSc and MSc in Electrical Engineering from the University of Technology in Baghdad and a PhD from Newcastle University in the United Kingdom. His academic journey began in 1995 at Al Ma'moon College, and in 1996, he assumed the role of an assistant lecturer at UOT. From 1997 to 2002, he served as a program coordinator at the Faculty of Engineering at Al-Tahad University in Libya, and then he later joined Sohar University in 2002. Hussein is a professor at Sohar University in Oman, and he also holds the position of a visiting professor at UKM in Malaysia and Newcastle University in the UK. Currently, he is the chair of Emerging Renewable and Sustainable Energy Technologies at the UNESCO Regional Center for Quality and Excellence in Education. Please welcome me in joining, and please help me in welcoming Professor Hussein to the stage.
Thank you very much for introducing me. Assalamu alaikum wa rahmatullahi wa barakatuh. Ladies and gentlemen, I'm delighted to be here. This is my first participation in IEEE Power Talk, and I will share with you some of really important for vision, Oman Vision 2040. By the way, I'm academic. If I cannot stay here I have to move on the stage, but seem to be, I don't know, is it okay? Okay. So what happened, I mean, everybody knows Oman Vision is amazing. They dream with big goals and or objectives, and there are, let me say, with these goals, several requirements and with the time. Okay. Hello. Is it okay? Okay. So, hello? Okay. So with the time, I mean, when we talk about 2040, we are not far from 2040. I mean, because it's not just up to the 2040. We have stages, which is several. I think I have to. It's not working. I will back here. Thank you very much. So what happened is Oman Vision 2040 is a big dream, and the objectives for this dream are many, but with time, there is a plan. There are several requirements, several needs to be fulfilled to reach 2040. It's not just direct shot to the 2040. So what happened is, this particularly I'm talking here about renewable energy sources with part of the, let me say, natural sources. So the project is not only related to electricity companies, or let me say one or two entities such as the Ministry of Energy. It's a big project. It's cover the whole country. Everybody should take share of this project. I mean, if we keep dealing with this project as it is just one or two entities, electricity company or Ministry of Energy, we cannot reach to the goals which has been put for 2040 in terms of reaching, as example, 2030, 30% of energy coming from renewable energy, or 2040 where there is 35 to 39% coming from renewable energy, or even if we look to extend it to zero carbon emission in 2050. Also, these are important plans, big dreams, but to reach to the point that we meet our dreams and our objectives, everybody should work on this. So strategically, I will present here, as you can, 3 points. One related to innovation, and one. But let me start with a little bit old data taken from International Energy Agency. They're talking about up to 2022, just 3 years back, because I would like to highlight the situation 3 years back, and then I will talk about the present and the future. If you can see here, the energy, let me say, mix used to generate electricity in Oman is almost fossil fuel, talking about natural gas mainly, just fossil fuel, or let me say diesel or oil for rural area, like, as example, Masira, which is 100% fossil fuel. This is not right. And I remember a long time back, I'm in Suhar working for the last 24 years, and always I've been writing in media or in TV, I talk about the diversity, and we need to look to the diversity of energy sector. And now the situation changed. This is old one, okay? I know that it is changed, and several, let me say, energy sources participated. But as I mentioned, it's not merit of one entity, several entities, and policy is a pillar here. Here I try to summarize the related policy in Oman. Just it went through stages, starting from 2004 National Energy Strategy Framework, then Oman Vision 2040, which is to prepare the future for Oman on different sectors, but here we are focusing on energy, and renewable energy definitely is the main contributor, and then energy development policy, and then national energy diversification strategy in 2019, and then electricity market liberalization, then the launching of 2040, One Vision 2040, and then national hydrogen strategy. Hydrogen became an important player in the game, and then net zero emission by 2050 commitment. This is what happened in the last, let me say, 20 years, and it's good if I highlight this to people related to the energy, let me say, the policymakers, that it's important to apply ADRI technique, approach, deployment, result, improvement. Always we revise the policies. It's a good practice because we need to evaluate if the policy is working or not. Do we need to improve it or not? As example, benchmarking with nearby countries and see if our policy kick the market to a new, let me say, opportunities or not. This is important. So after the result, after the deployment result, we need to look to improvement, improve, revise, and improve our policy. And last here, but not least, is as I mentioned, it's not a project for one or two entities. It's related to everybody. So if electricity company, definitely they are leading, energy, Ministry of Energy, they are leading also, but other entities. So in the next few years, talking about after 2025, energy efficiency program, we need to focus on, let me say, efficiency, building codes, standards, and the other issue is, which is important from my side view, is national awareness campaign. We need to aware people so they can participate in this. We recently launched the UNESCO chair in emerging renewable and sustainable energy technology, and one of the main projects I started with our team there is this national, let me say, awareness campaign. As you can see, yeah, this what I mentioned about the targets 2030, and not only energy, the carbon emission, but back to the awareness I mentioned. We started doing awareness. This is one of the projects we just started at Sohar University, which is called Seed for Better Future, where we will make awareness campaign national level. Many people participated, the students, teachers in the schools, university lecturers, to educate people from primary school, elementary school, secondary school, because if people know what is their role, then we can easily sell the technology for them. Now, as you can see here, in 2000, 2010, 2022, the electricity generation is almost double. But when we back 20 years, we can see no mentioning for renewable energy. But go to 2022, it's start appearing. And if we look to 2025, definitely there is much came. Several, let me say, power plants are working every 2 to 500 mega, 500 mega in Munah, in Adam, and we hear daily that there is some projects coming on and launching soon to improve this sector. But if you see the numbers, you can see that the solar is let me say, leading here. And this is what the study in 2008 mentioning that solar could be the priority for Oman in terms of renewable energy. Now, the other issue, which is good, is if we look to the energy consumption by person for the GCC countries, we will find that the person in Oman use less energy. More effort could be happen here, help to approach our goals in 2040 vision is to educate people so they know how to use efficiently the energy at home. We need to let people know how they build their houses, how they deal with energy in house, in office, in company, in the street, in the mall, in the car, everywhere. So people have to participate in this, let me say, campaign for Oman Vision 2030. I mentioned for the policies, but actually these policies linked to Oman Vision 2040, which have several, let me say, important objectives. But in terms of, let me say, natural resources, we can see that Oman Vision make it as a pillar, natural resources, to feed the economy, okay? And they put goals after goals, plan after plan, action. And they are working on this, but we don't want to reach the minute when we approaching 2040, we are delayed to reach our good planning, good revision, working with other entities will help a lot. And also, this is also related to sustainable development goal because the need, it's kicked in 2015. Yeah, it's 2015, and I just started. Okay, and by the way, I'm supposed to talk 2 presentations because my colleague Kamaruzzaman Sufyan is supposed to talk about Malaysia if he couldn't make it, so I'm supposed to have 30 minutes. Anyway, So the other issue is, as you remember, Oman Sustainable Week, this is a good practice. We need to have such a practice, Oman Sustainable Week, IEEE PowerTalk, and other, let me say, practices. But the other issue is Oman starts working on the international treaties such as this Paris climate change. Now, we have national diversification strategy, we have net zero emission 2050, but this is not enough. Other entities need to work with us. I mean, not only electricity company here, most of people from electricity sector, there is energy, Ministry of Energy sector, other entities need to work with us on different other levels, such as on housing, transportation, industry, because if these sectors are not working, really the task will be very difficult to reach the objectives of 2040. And this also take me to highlight that the policy I mentioned here need to be in line with other policy related to these sectors. So they don't work in a silos, no, everybody work with everybody. In this way, we can reach to something and fulfill our requirement. Now, on building policy, I just highlighted from International Energy Agency that you can't see cross, it means it's not available in Oman. These are parts need to be covered in terms of building policy. In terms of transport policy, we have only charging infrastructure and other cross, it means we need to do some effort here. And in terms of power policy, which is related to people in this room, we have renewable energy auction and renewable energy target. Others are not here. We also need to look to these. I'm around to finish just a couple of slides and we'll finish. And innovation is the core of a transition, which related to advanced renewable energy technology, to energy storage innovation, to carbon capture and utilization, to hydrogen production and distribution. We need to consider this in the transition. Innovation is the core. And simple, this example, the previous example talk about using fossil fuel. Fossil fuel, much of waste is there because of fossil fuel generated somewhere and transported to the power plant, and inside the power plant there is much losses. But having innovative in using, as example, hydrogen production, which is really interesting project in Oman, with all the obstacles could face this project because we are, in the middle between East and West, and the customer are either in Japan, Korea, or in Europe and US, but still, having such a project is innovation way of thinking, and it will be great if we can have part of the production of hydrogen to be utilized in Oman different application. Flexibility of energy sources. People talk about here dealing with from generation to distribution, transmission, distribution, storage and demand, but we need to make our, let me say, network more flexible by having, let me say, hydrogen working to feed this network, electric vehicles, heat, here maybe in Oman, cooling, not heating, okay, also could be innovative. And for efficiency, it's not only the grid efficiency. You can see energy efficiency, land efficiency, water efficiency, comfort, and so on. Efficiency could be everywhere in our world. For that, I say it is not one or two entities, is everybody should participate in this. And electrification, clean transportation, we start seeing this, but we need to expand it. Nuclear energy is a discussion in the region. I don't think Oman for the time being is ready for this, or they have need for this. And you see rooftop, I mean, solar is not working still in Oman. People are not, interested. But in nearby in Dubai, they have much. So we need to think why it's not working, what's happening here. We need to revise. And also, as I emphasize the net zero energy building, or nearly net zero energy, or what we call it here, let me say, energy neutral community. We've been discussing this morning about this topic. Let's start it at least in rural area. I'm around to finish just a couple of slides. This is my conclusion almost. So we have a 2025 now, another 5 years, 2030, and then 2050 to reach the zero emission. For this next few years, we need to focus on energy efficiency and sustainable energy. Net neutral community because we can work on small communities. Smart grid and decentralization. In 2030, we need to look more on transition toward hydrogen economy, the launch of hydrogen. And as I mentioned always, hydrogen should not only produce here and transport outside, we need to utilize part of it here too. I mean, it's very important to produce it and use it here. And last part is 2050, when we talk about energy supply stability and the hydrogen economy, we need to look to advance hydrogen system. So it's not only in electricity company, but also in application, other application in housing, industry, and transportation. One example, and I will stop talking, is the up to 2050, just this is the upper one is the global situation, but here the blue and the red is for Oman, the projection. The blue is talking about the demand. Will keep increasing, which is normal everywhere in the world. But the red one here is the reduction will happen in the utilization of fossil fuel. Okay, we use AI here to find the projection, and you can see that with time, more energy sources will participate, more energy technology will participate, the more reduction in fossil fuel utilization. So we want to upside down the picture, okay? It was in 2020 when I started talking, less than 1% renewable energy. We need to reach more than 37% in 2030 to approach Oman Vision 2040. Thank you very much.
Thank you, Professor Hussein, for shedding light on multiple technologies which can enable Oman's decarbonization journey. Next, we have Hilal Ghaithi, who is a key accounts manager at Agrico Middle East, bringing 11 plus years across oil and gas and OQ roles in energy optimization and grid resilience. He'll look at CCUS opportunities in energy-intensive industries where efficiency and carbon solutions intersect. Hilal, the floor is yours.
So, Assalamu alaikum. Good morning, and thank you, Sadiqa, for the intro. And I'm really happy to be part of the energy conservation session within IEEE PowerTalks 2025. So today's topic is a kind of unique technology to prove the concept of the carbon capture, storage, and utilization within the Middle East, mainly in oil and gas sector. We have implemented this technology within the Middle East, mainly in Abu Dhabi. So what I will do, I will just go through a quick intro about Agrico, who we are, what we are doing, which are the different sectors that we are covering. And then immediately we will jump into detail of the project and the outcomes out of it. So Agrico is one of the global energy service company established almost 60 years ago, and they are working on the Middle East on the last 30 years. We are more than 7,000 employees across the globe, and we are working in more than 68 countries. We have like a total fleet of our own equipments of more than 10 gigawatt, and just to make it clear that all Agrico fleet is just a rental base, so that we are taking care about the identifying the solution, providing the operation and maintenance, and sustaining the solution through all the project period. So which are the different sectors that we are covering? We are working in utilities, renewable energy, construction, manufacturing, shipping, events, oil and gas, downstream and midstream industries, data centers. And then we have the manufacturing as well, the food industries, the government, mining, and telecommunication. So now we will go directly to the topics that we are really interested in, and we really looking forward to have such pilot project within the country to prove the concept for different sectors, how the carbon capture and the utilization is working, what are the key benefits out of it, and how we can just scale it up to have it like a large industrial scale. So the topic today is implemented within one of the big oil and gas companies in United Arab Emirates, mainly in Abu Dhabi. So the main idea was to remove, as phase one, to remove around 1,500 metric ton per hour of CO2 from the ammonia production plant. Why is that? Because, you know, for some Europe countries and the Asian countries, if you are not providing like a premium product, for example, like blue ammonia, green ammonia, blue hydrogen or green hydrogen, you will not be allowed to sell your product to that countries. So this was just an initial initiative that requested by our client in order to develop the solution and start the implementation immediately. So what's happening exactly that? The plant is using the steam methane reformer, where they are injecting the natural gas into the system along with the steam. Then by heating it up, they are breaking the chains between the carbon and hydrogen, and we came up with an end product, like the main product is the hydrogen, along with the CO2 and the nitrogen as well. So the nitrogen then is reacted with the hydrogen in order to produce the ammonia. And the CO2 is already captured in a different system where they are using a counterflow absorber using potassium carbonate solution in order to absorb as much as they can from CO2. Then it will be injected in another separation unit where like a kind of regeneration of the amine, where the captured CO2 will be sent directly to the agrico system. So what we did basically, we just taking this captured CO2 from the system, and then we just cool it down by our chiller. I will go direct to that. So we are using like plate and frame heat exchanger along with 300 kilowatt VLTC chiller. And we have, you know, different size of that. And then what we are doing basically, we just send it directly to a storage tank. To store the liquefied CO2 is a bit difficult because, you know, you need to have like a special type of tanks that can store the CO2 because, you know, you will say or store it at high pressure of more than 23 bar gauge. Additional to that, it's a very low temperature as minus 19 degrees C. So then what we do basically, we just inject it into truck and we send it all the way to the desert. And the main purpose of that is to inject this CO2 into the underground to enhance the oil recovery from the oil fields within our client facility. So on the like injection section, what we have like two heat exchangers along with the water heater. So what we did, we just basically release the CO2 from the truck and send it through an evaporator system in order to ramp up the pressure as well as the temperature and directly inject it underground. So this, like you can say that is like a win-win scenario for both because you are capturing the CO2 and you are able to sell your product externally. Additional to that, you are optimizing on your upstream facility instead of producing instead of producing steam and you consuming natural gas, you will direct inject the captured CO2 from your facility itself. So in this case, you are saving the emission from both sides. So also there is like a kind of pump that injecting the, to enhance the CO2 pressure and injecting directly into the well. So what are the main significant successful that we deliver to our client is mainly reducing the CO2 emission generated during the hydrogen production to produce the ammonia. And then it followed by like a flexible solution because, you know, as I mentioned earlier, that the solution that we are providing is quite flexible. It's like a Lego, plug and play, and make sure that the this setup that we provided to our client, it will be a kind of unique system that developed for them only, and it will not be matching with other clients because, you know, we will need to develop another one for a different client. So then the capture and storage large volume of CO2. So the phase one is to reduce 1,500 metric ton of CO2. Then it follows by phase two of 18,000 metric ton of carbon capture. The deployment of a fully supported system include power supply, nitrogen injection, operation control, and site management. So we take all the responsibility and the ownership of our fleet as well as the site preparation in order to meet the client needs toward the net zero. And what we have else, I think that's it for the project that we have on the solution. Mainly, we will be more than happy to discuss it in more details because, you know, as for special clients, you will not be able to present all the technical details as requested earlier when we shared this presentation. However, we can take you more through our fleets and through our technology within the carbon capture and even including the energy storage, renewable, and all the systems that we have within agriculture. Thank you so much.
Thank you, Hilal, for presenting the CCUS opportunity, and hopefully in next year's IEEE session, we will have an example from Oman. Last on our speakers list is Engineer Amir Ibrahim Mustafa, the Country Manager for Oman at Gulf Experts. He brings more than 20 years of experience in energy management, HVAC, BMS, and smart controls, including major Johnson Controls projects across the GCC. He'll show how AI-driven EMS in Oman's commercial and industrial buildings convert data into continuous savings and lower operational emissions. Thank you, Dr.
You have mine? Can you hear me? Here is okay? Okay, good. So, good morning. Assalamu alaikum al-awwal. Good morning, everyone. My name is Amir Ibrahim, and I'm serving in Oman for like 2 years now. My company here since 7 years, and we started our main branch in Qatar since 15 years. We are serving in HVAC sector and energy and controls, focusing in power solutions and energy solutions, as I'm already certified as a energy management. Okay. Who has AC in his office? AC in his office. Do you have ACs in your office? Okay, imagine that AC without any control. And that AC only with on-off like lights. What will happen that time? Yeah, think with me. Once you feel hot, you go there and start the AC. Once you feel cold, you go there again and stop the AC. Yes? Okay, good. This is the traditional EMS. EMS is the energy management system. This is traditional one. Same like you are using your car. If you are using your car and pushing your acceleration, the fuel, brakes, fuel, push fuel, and again, once you come near to any another car, push brakes, this is called traditional EMS, traditional energy management system. Then we move to another era, which is a smart EMS, using building management system, using BMS, using PLC, and using also some thermostats. Again, we'll take that same example. In your AC, in your office, you will find one thermostat there, supported to the wall. So that thermostat actually doing the same what you are doing. Once that thermostat senses the temperature is high, so thermostat gives signal to the AC to start, or to the coil to open, then the cold water will flow, then you will feel a little bit cold. Again, when the sensor inside the thermostat felt like temperature is low now, again gives signal to that valve to close. This is the smart EMC. This is what we call a smart EMC, smart energy management system. The third level, which is now we are applying in our projects in Oman also, and we have, alhamdulillah, achieved a good results. I will show you later on that. The AI-driven EMC. The AI takes a decision based on human feelings, or based on human nature, based on human practices. The AI, before the human feel that temperature is high, the AI take the action to decrease the temperature. So AI is giving signals directly from the cloud. After some analysis, I will show you how to do this, to the control system, the local control system in your existing building, to open or close the AC based on your practice. So the AI learns from our practice. Usually, this is usually happening. If you see if you are opening your mobile every day at 8 a.m., suppose. So once you open your mobile at 8 a.m., so AI keep tracking your behavior. Once your behavior is same for certain days, so again, like after 10 days, the AI at 8 a.m. will open your mobile instead of you directly, because he's tracking your behavior, and because of that, he's taking decision to increase or decrease the lights or the AC or the power, whatever, inside your organization based on your practice. Okay. So we already spoke about this AI-driven EMC. It's a combination between artificial intelligence and existing PLC in your organization. It's only about combination. So what they are doing here, we are connecting some algorithms to your existing system. Then that algorithms can take decision based on what's happening in the system. How to save power, how to save energy, how to reduce the consumption, how to decrease the peak load. We have peak load always, and the tariff always goes to the peak load. So we need to reduce the consumption because of cost. So we need to reduce the cost. We need to reduce the cost of bills. So we need to decrease the peak consumption. Peak consumption always comes like from, in factories, usually peak consumption between 12 to 3 p.m. and in commercial buildings between 9 to 12 p.m., 9 a.m. to 12 p.m. This is the peak consumption. How AI can fix this problem to decrease the peak consumption? By taking decision before the peak consumption comes. Suppose you have a refrigerator in your home, and you will think like AI, okay? So you will open the refrigerator every day and see if there is water inside that refrigerator, okay, how many bottles there? 5 bottles, okay, that 5 bottles will be enough for me for 1 day, suppose. So the second day, I will come and check how many bottles there, only 3 bottles. So what I will do, now I will go and bring another 2 bottles as a just save to keep it in our refrigerator in case we need it. And again, every day, the AI looking for your organization and looking for your cracks inside the organization and the big load where, and when you offload the machines, when you upload the machines, whatever. And based on that, it takes decisions in 3 layers. So we are doing this in 3 layers. First layer, data acquisition layer. First, to do this, we need to collect all data from your organization, from your factory, from your facility, from a building, whatever. Even also homes, if you need to use it at homes, which called smart homes now, if you hear about. But smart homes, not traditional smart homes. It's actually AI smart homes, intelligent smart homes. If you are using intelligent smart homes, you will find this, what I'm telling you. Like now in Sultan Haytham, new city. The Sultan Haytham city using this technology actually. And we are part of this as a Gulf expert. So here, we are collecting all data acquisition, all data from the existing systems, by sensors, by smart meters, by IoT devices. What the meaning of IoT devices? Anybody knows? Internet of Things, yes. Internet of Things. Internet of Things that we can put sensor, by the way, you can use it for humans. My mother, before she did, I used that for her because she had sugar, and I need to monitor this from away. So we put one device connected to her body, always connected to her body, that device with a small sensor, and that sensor gives me reading on my mobile to monitor her sugar. So once I found that sugar goes high, I just calling her, are you okay, everything's fine, you have to take your medicine now. This is Internet of Things, the benefit of Internet of Things. Now we are using this in our technology. Second, AI processing layer. AI processing layer, we are using 2 main or focal points. One, local computers to connect that data to that computers. Second, AI cloud. At the cloud, we are putting some algorithms, AI algorithms in that cloud, and they are connected together, cloud and the local points, with machine learning and with big data storage and with some blockchains. We are doing some analysis for that data to predict what will come in the future. Now we have, in Oman here, we have system for prediction of like weather, some changes, like what happened before. Okay. Building equipment control. So again, we connect that data coming from cloud to the local point, which is the computers, to the existing BMS. We will not throw the BMS, we will not take rid of that all BMS or PLC systems already existing in your building. Actually, we will set up our system to that already existing BMS or PLC. In action, we are using machine learning and predictive actions to protect your equipments. We are not waiting, or that system not waiting for your existing system to get some defection, to call our team to go and do like corrective maintenance. Actually, we are predicting the problems before it happens, and we send our technicians or engineers to fix that problem before it happens. And this is reducing actually a lot of effort and cost. We have some success story in healthcare facilities, government buildings, and manufacturing plants, and we already achieved that numbers. In this year, during this year, we achieved that numbers. We saved like 22% of total energy consumption in some government sector here in Oman, in Muscat especially. And one manufacturer in Sohal, we are already saved 17% of bake load, because in manufacturing, they are, the cost of pills comes based on the bake load. In healthcare sector also, we saved around 19% of power consumption. So the main result as a like quantitative results for our projects here in Oman, this happened only in 1.5 years, by the way, not more than. We are doing, these numbers you will find, like energy saving from 15 to 25% as based on the category of the building. 10 to 17% peak load reduction based on the category of the, or the largest of the, or hugest of factory. 20 to 30% maintenance optimization by predicting the problem before it happened, and we are sending our engineers to fix it before it happened, as a predictive maintenance, not as a corrective maintenance. And all our projects actually, ROI of our projects is between 12 to 18 months only, which is very super in projects. Okay, very quick. We spoke about this already, some benefits about this, and also this cooperating with Oman vision of 2040 to reach net zero. Because by this AI also, we can reduce the carbon emission, the CO2 emission. We have that service in our company, by the way. We are going into organization and take the CO2 footprint. So we are taking that CO2 footprint before we apply our system, and after we apply our system, we are again go to your organization and take that again from footprint of CO2 and see the difference. This is global target now, the CO2 emission. The landscape of that project, of that normally systems, we are facing a challenge with legacy buildings here in Oman, because legacy buildings using legacy systems, and that legacy systems should be updated to the, or upgraded to the newest versions. If the system using all the protocols, like closed loop protocols, that cannot be integrated with AI-driven systems. So the system in your organization should have open protocol like BACnet or whatever. And finally, vision for the future. So we need to reach this together. We need together to focus on AI-driven systems. And by the way, the AI-driven systems not should work separately or individual, away of the human. No, the human should interact with this, because based on the human behavior, that AI will give signals to do whatever required in our existing building. If any questions, I'm here. Yeah, thank you.
Thank you, Engineer Amr. May I invite all the speakers to join the panel discussion for a 15-minute Q&A session. Thank you once again, everyone, for the very insightful presentations. I myself have many questions for all of you, But I'll first open the floor for any discussions and questions from the audience before I go to my questions. Any questions from the audience?
Assalamu alaikum. My name is Haytham Raspi, specialized in energy efficiency. My question is about Super ESCO, since we have Oman Net Zero Center as a Super ESCO and also OQAE. So we have two Super ESCOs, so how is it going to work? First question. Second question now regarding new solutions and new solution providers like the Gulf Experts solution using AI. So I'm interested to hear the panel's opinion about it. About the new solutions, yeah.
Thank you for the excellent questions. Dr. Esma and Alan, would you like to go Super ESCO first?
Thanks, Haytham, for the question. So just to, I suppose, maybe start on it and Dr. Asma can finish. So Super ESCO is, I suppose, a term used for a company or corporation to make these projects easier. So Super ESCO will generally bring the finance, bring the ESCOs to the table, will convince the end user to implement these types of projects. So we're using the Super ESCO as a phrase, I suppose. So OQAE is a Super ESCO for the projects that we have within OQ and perhaps outside of OQ into the future. This Super ESCO type model that Oman Net Zero Center are implementing is for the government sector, and they will act as a Super ESCO for the government buildings, but maybe can continue on.
Thank you, Alan. Actually, the Super ESCO, it means it's not two separate things, rather than just a terminology that we are using to define what is the structural process for energy performance contract. So based on that, if we are taking the government buildings as its own, as a project, we will talk about Super ESCO under the Oman Net Zero Center. If you are saying Super ESCO for the private sector, is one example, IQ, which is Alan speak about it. So under Oman Net Zero, we are only represent the government buildings and the government sector as a Super ESCO. And in terms of the other project is representing the private sector, which is related to the other buildings rather than governmental buildings.
Thank you. The second question was on the Gulf Experts on the new technologies. Engineer Amr, would you like to?
I just need to be clear about that question. You're asking about how to apply that technologies?
Actually, my question is, I wanted just a general idea from the Super ESCOs or the ESCOs in general. What do you think about applying new technologies, especially with the clients? Sometimes they might be hesitant to apply those technologies. So maybe you can give an idea about whether clients, there's an issue or difficulty when dealing with clients or presenting them with the new solutions, such as yours. Yeah.
Yes. I need to guarantee for you that everywhere we reach it here in Muscat, in Oman, beyond, even also Muscat. And we spoke to them about that systems. They agreed immediately to apply that system, and at least for a demo system that we can apply to the building. After that, they can take the decision based on the facts, the reality. And that number which shown in our presentation, which is the reality in Muscat, which is very interesting. So, please, you need to apply the system in your building immediately. And by doing this, we need to make survey first, like visual inspection. After that visual inspection, which is level 1 ASHRAE audit. After level 1 ASHRAE audit, we can decide if that building able to be applied the system directly or not.
I just want to elaborate on this possible, so maybe Dr. Esma and Alan can shed light on your interest when you pursue a Super ESCO model for using new technologies like AI. Would you apply it in the contracts which you're pursuing?
Yes. So energy efficiency is a never-ending story. We signed our first energy efficiency project like maybe 70 years ago. And always you are you need to understand that each project is specific. University is specific, an industry is specific. So you need to visit and you need to do what we call the audit, detailed audit, in order to understand, what will be the solution you will be implementing. Understand also what is the structure of the electricity market, because you are expecting a certain payback. So you cannot do whatever you want, especially for the AI-related solution. You need to have access to the data. And what we see on sites, we are performing lots of projects on energy efficiency in the region, multi-million of contracts. And what we see is we have difficulties to access to the data. So we need to have a global approach, which includes financing. Of course, we have here people who can finance, people who can deliver the project. We are part of this solution. And you need to assess the global solution and the global scheme in order to see how you are going to develop this measurement. You need to have the data in order to monitor and analyze. So AI is not the solution, it's part of the solution. But the first thing is the expertise for me. You need to have the right certified people who can visit the site, understand the needs, collect the data, speak with the people and the way they will use the energy. And after that, you can start selecting, side by side, the right technology and implement it. But once again, it's a global exercise, and you have the financing part as well to take into consideration, because nobody will invest if there is no payback at the end.
Okay, thank you very much. But just I would like to highlight something very important here is the new technology. We need to be careful. I mean, the situation here in Oman or in the region is different when we bring technology from outside to the east or west, because the weather there is different. And I give one example here. The solar photovoltaic systems, large scale. We know we are talking about here, we may approach soon 10,000 megawatt solar photovoltaic. Nearby United Arab Emirates Kingdom, Saudi Arabia, they have a huge project, especially when it's related to hydrogen. But still the problem is temperature and dust. They brought technology, the decent technology, but still they face a problem. It's not working. Simply it's not working because dust is not there in Europe or in US, or not like the situation here in desert area. And I remember 2 years back, I worked as a consultant with DEWA team. We put the first protocol ever for the installation and maintenance of solar photovoltaic large scale in desert area. And if you ask now anybody working in this field for large scale, every two or any other, they are facing real problems. Robots is not working, and several technology they apply is not working. In United Arab Emirates, the same thing. So it's a general, not only for energy sector. Any technology you would like to bring from outside, you need to be careful. Is it working in your environment or not? Because we are different from Europe.
I will just add a few things that in my Net Zero Center, we are up in the floor for any new technology. Just we need proving the concept first. Without proving the concept, that concept, it's work for a man, it can be applicable, achievable, economical-wise, it can be done for a man. If you're proving that, we are welcome to use any kind of technology unless you have the proving of the concept. That's it.
Excellent. Any other questions from the audience?
Assalamu alaikum, Hilal Hadi. Actually, my question to Doctora regarding, I have seen when you are showing the reading of the data or recording of the data, you mentioned it's monthly for zero. How that can be happen?
I didn't get your question. Can you repeat it or rephrase it?
No, I mean to collect the data, to monitor the zero impacts or effects from other resources like renewable EV and so on. You mentioned, like, maybe I understand it correctly or not, monthly. So how we can collect this data monthly and we put it in our national record? That's the...
It's not just monthly database, rather than it's a real-time management recording of the CO2 emission. And this is happening through the Mizan platform. I'm not sure if I'm getting you with the Mizan platform, okay. each company in Oman or each entities in Oman has to be enter in the platform and registered with the Mizan platform. Through that registration platform, they will give you information about how to register all your energy CO2 emission levels and so on. And we have the team with Dr. Mohamed Al-Kalbani. They can guide you how to be implementing all these data sets inside the platform. Later on, when you open that platform, you can read it as a real-time database. So you can see all the sectors. For example, let's say the industrial sector. You can see it, how much is CO2 emission in Oman in that sector. Let's say the building sector as well. It can be reflected on the platform.
So you mean the Mizan now, we have to activate it from our side, as maybe I'm talking here like a distribution company.
It's already activated. It's already worked. We are now in the stage of having all the entities to be registered inside the platform to make it happen.
Yeah, I mean activation of the registration. That's what I mean.
Yeah.
Excellent. And that will be announced for us, correct?
It's already been shared with most of the company, especially oil and gas. They are starting with the oil and gas companies.
And how about we are electrical companies? We have to involve here also, like distribution company. I'm talking.
It's going to be for whole sectors in stages. Later on, it will be announced.
Okay, thank you. Clear.
Thank you. Peter Stiles, Zeta. Apologies, I'm losing my voice today. I try to speak close to the microphone. I have a question for Professor Hussein from Newcastle University. I was interested in what you said about changing people's behavior. And I wonder whether you agree with me that profound changes in behavior probably going to need economic incentives. Do you hear? We'll need economic incentives. I think changes in behavior will need economic incentives. And for example, Alan's helping, yes? I'm so sorry about my voice. For example, taxation could be used to make consumption of hydrocarbons relatively more expensive, and to make consumption and investment in solar energy less expensive. Would you agree?
I don't know. I discussed with my colleagues here. So based on what he explained to me, about your question. Sorry anyway. You are talking about solar photovoltaic and the consumption, and if this is feasible. Yeah, then I'm right. Okay, let me answer this question. Now, today, based on the International Energy Agency and in general, the entities related with the energy technology, the most cheapest technology in the world today is the solar photovoltaic. No doubt. It's even cheaper than the coal, any other technology. This is clear, okay? And for that, you can see that and many other reasons that the region is moving in this direction. We never imagined 20 or 30 years back that the region here, when 1/3 of the oil produced and transport everywhere, will look to solar photovoltaic. Nobody expected this. But today we are talking like it's a fever. Everybody starts having larger scale. We talk about on 2030, 2023, Oman talk about $20 billion of green hydrogen based on photovoltaic. 1 month later, we hear in the media about Neom city, Kingdom of Saudi Arabia, talking about $8.7 billion project. So the region is moving in this direction because it's feasible. And connecting to hydrogen is smart, really smart. But it comes with some obstacles. One of them is the market. Okay, to make it more feasible, market is very important, because now the cost. On my best knowledge, last year the cost of 1 kilogram of hydrogen in Europe it's $3 per kilowatt. Sorry, per kilogram. And the International Energy Agency, they expected that 2030, it will reduce to 1.5. The price will go down. With many old players producing hydrogen, with many new players coming to the game, the price is going down. So just selling hydrogen will not be, feasible. We need to use it also. This is the transition. Part of what we produce, we need to use it here. But even if you kick the hydrogen from the game, just look to the solar photovoltaic. It's really important investment. And for Oman, I'm working for 24 years in different cities in Oman to look about the environment, the solar radiation, different type, dusts, characteristics, temperature, places, where are the right places, what is the right technology, I can't tell you, and I'm sure from what I'm saying by numbers, it's tangible, that it's feasible in Oman and could be the most place in the Gulf region to be feasible, especially in the north part of Oman, because of geography, because of mountain of Al-Hajar, because of the sea and the dust characteristic itself. So yeah, I totally support, and it's feasible. Just we need to how to play smart here. Okay, I answer.
Yes, if I can complement, so EDF, I'm the CEO of Dalkia, but we are part of EDF, and EDF is an energy developer. We have developed about 10 gigawatt of a solar project in the region, and we have been awarded 500 actually completed megawatt in Oman. So of course this technology is very efficient, and again I'm coming back to the same idea of having something which is profitable. So the price according to the technology is now going down. So it's profitable to do this kind of system according to the price of electricity on the market. The most important question is how you can store this energy, because you will be producing lots of energy during the day. You need to propose solutions. So the solutions are existing. Of course, hydrogen is one of them. We are working on the project Hydrom in Oman as EDF, so we are part of the solution. I see as well lots of projects now with batteries. Batteries is something we are also working on, and we see lots of projects in Middle East on batteries. And the last things I want to mention is pumping storage station. So I don't know if you are familiar with that, but we were working in Dubai on a Hatta project. It's a 240 megawatt. It's 2 reservoirs of water. When you have an excess of electricity during the day, you will pump from the lower reservoir to the upper reservoir. So during the night, when you have no electricity coming from the sun, you will release this water from the upper reservoir. You have a turbine in between, and it will produce electricity. So you need to address globally these kind of questions, not to have excess of electricity, for example, coming from solar, and you don't know what to do with that. And this is exactly what we are doing as EDF to tackle the situation globally and to propose global solutions.
And I think this is the fair comparison, is to not compare only solar for the morning hours, but more of a 24-hour solution against gas or any other fossil fuels. Yeah, great, thank you. Any other questions from the audience?
Hi, Faisal El-Kindi, specialized in energy efficiency. I would like just to recycle 2 of the questions I've heard. The first was from Dr. Haytham regarding the validation of the solutions for the energy ESCOs, let's say. My question is for Dr. Asma. Is it the Oman Net Zero Center's role to validate the new technologies and new solutions, or the ECMs? We all know that since these are becoming more familiar and we are having new technologies every day, to avoid the greenwash, let's say, in the upcoming ESCOs and so on. So is it one of the roles that the Oman Net Zero Center will be doing? My second question is, I would like to recycle, I'm not sure if I captured it correctly, but the gentleman was trying to ask about the incentive regarding to Dr. Hussein. The question was directed to Dr. Hussein. Since you talked in your presentation about the participation of the whole sector across all stages, do you think that there should be a more incentivizing economically for more participation from other participants, let's say, other than the government? And do you agree that the economic aspects are the barrier in that area? So those my questions. Thank you very much.
For your first questions, if we are responsible or our role to validate the technology, my answer is no. It's not our role to validate the technology, rather than if you have that technology ready to the market of Oman and you have proving the concept and you are willing to do so, and you are saying for the Oman Net Zero Center, we have this technology and we can apply it in a scope of work as a pilot study project, and this is the proving concept and this is the result, and you can, yes, apply it for whole of Oman if we have a project for that technology in Oman. And we will help you to how to do so further. For example, there are a couple of companies that are coming about street lighting, and we need the proving concept. And the municipality of Muscat municipality, they have been working with that project, and they having a small project under proving the concept. If it's proved concept, why not if we are implemented for the whole of Oman?
Since the sector is developing at the moment for the energy efficiency, and it's changing, and the structure is being, let's say, figured out, do you expect that there will be a layer of verification, not just for technologies, but for all products that can be involved in the ECMs?
Yes, of course. Any kind of a project, exactly, for energy efficiency related to the buildings, there's going to be a new role of roadmap, how it's going to be implemented for the building and for the whole sector. So for the governmental buildings, industrial buildings, and social building, which is for the social housing units, for example. One thing is that how we are implementing the Code of Oman, Energy Efficiency Code, what kind of appliances has to be done in Oman, for example, ACs, lightings, what kind of coefficient of performance of these appliances, what is enough what we have done so far in the standard related, or we have to do more in Oman. So this is related to our scope and our role.
Hello. Yeah, just a compliment on that. I think we're almost out of time as well. So just maybe 30 seconds on that. So anything to do with innovation, pilots, new technology, OQ as a standpoint, can do trials to prove the concept. We're always happy to welcome companies to pilot their projects if it's around CO2 emissions, energy saving, water savings. We can find a solution for that. We can prove the concept and invite Omani companies in to do that. And the second point, and it was mentioned earlier, for the ESCO projects, the ESCOs always welcome innovation as well, but they're tied with a commitment as well on the savings that they give as a guarantee, and also on the payback of the ECMs. So this is a constraint from an innovation point of view, but they are always looking for these type of solutions. But as I said, with OQ, we can help you to prove the concept, be it any technology looking at lights, pumps, HVAC, chillers, etc.
Thank you very much. Just ask two questions, one for Dr. Asma. I just would like to add comment here regarding prove the concept. I totally agree with Dr. Asma. We need to prove the concept. But, I mean, the concept could be proved in other countries. We cannot copy-paste here. We need to prove it inside because we are different. And as I mentioned, I mean, if you ask me, I'm working in the field for the last 3 decades in energy and solar photovoltaic. If you ask me, what is the best cleaning method for photovoltaic, I cannot answer. There are many, because we are different. DIWA, as I mentioned, I work with them with all what they have, infrastructure and experts on there. They still struggling to prove the concept in several things. For the question you directed to me, I mean, so solar photovoltaic could be spread. I mean, I mentioned to the ADRI technique is revising our policy and see how to improve. It's good practice. In United Arab Emirates, my working with them show me that they face a problem that the people more interest in having solar photovoltaic on their houses, they're building the private sector, around 3,000 mega, coming from private sector. Sometimes it's more than the need, the demand, and they cannot shut down the conventional power plants. This tells you that there are some good practice here we need to look for. Why they use the photovoltaic, the public, why don't we use it here? We need to revise and to do improvement. Yeah, there is several opportunities. The market.
Sorry, we have to end. Unfortunately, people are getting hungry.
I'm academic.
We can
so
continue the discussions in the lunch break anyway. Honestly, it's very refreshing seeing Oman finally taking the stride and creating the ecosystem for energy efficiency with Oman Net Zero Center leading the Super ESCO model with OQAE following as well, and other private sector participants entering into the ecosystem to enable Oman to really save on the gas and on the carbon emissions. Thank you very much, Dr. Esma, Steve, Alan, Professor Hussein, Hilal, and Engineer Amir for the very interesting discussion. We'll definitely continue the discussion in the lunch break. We'll hand the certificate to speakers. دكتورة أسماء. ستيف لمعون. آلن. Professor Hussein. Hilal Ghaithi. And Amir Mustafa.
And the trophy for Siddiqa. Thank you so much for moderating the session. Thank you, guys, and see you after 45 minutes back in the hall to resume our sessions. Thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh. Good afternoon, ladies and gentlemen. I hope you have all had an insightful and inspired time at IEEE PowerTalks here in beautiful Oman. Welcome to session number 6, last session of this conference, titled Sustainable Energies, Renewables and Storage. I am Mazen Al-Shidani, and I will have the pleasure of moderating today's last session. We have an excellent lineup of speakers who will share their experience, expertise on key topics ranging from renewable energy integration, hybrid projects, energy storage, and development of local supply chain. Each presentation will be around 15 minutes, followed by panel discussion at the end of all presentations. As this is the concluding session of the conference, let's end on a high note and encourage you to stay engaged, take notes, and share your questions during the Q&A session. Let's not waste more time, and please join me to welcome the first speaker. We have Mr. Haytham Saif Al-Umairi. Mr. Haytham, he is the head of Business Development Unit at Sohar Port and Free Zone, where he has been instrumental in driving commercial strategy and attracting international investment. Mr. Haytham holds a master's degree in shipping and transport and currently pursuing another master studies in hydrogen economy and technology. He has played a key role in shaping Sohar's vision for sustainability and energy transition. Mr. Haytham, he is a renewable engineer researcher with a focus on battery technologies for grid-scale storage. He will be talking about opportunities for developing local supply chains for solar panels, wind turbines, and hydrogen infrastructure. Mr. Haytham, the floor is yours.
Can I get the clicker? No? Assalamu alaikum wa rahmatullahi wa barakatuh. Good afternoon, ladies and gentlemen. I'm really pleased to be here today with you and sharing the insight about Sohar Port and Free Zone initiatives when it comes to the energy transition, the latest developments within Sohar Port and Free Zone, and how we can support also Oman Vision 2050 toward the neutrality on the carbon initiatives. So this is Haytham Al-Umairi. I would talk today about the localization of the supply chain on the energy transition and what we are currently doing in Sohar Port and Free Zone. Little bit or background about Sohar Port and Free Zone, what we are doing and who we are. Sohar Port and Free Zone is a JV between Asyad Group and the Port of Rotterdam from the Netherlands. The main purpose of this JV is to develop the infrastructure of the port and the free zone, attracting the foreign direct investment also, and maintain a healthy and sustainable growth when it comes to the employments and developing the local economy of North al-Batina. We started in 2004 as a JV. And currently we are talking about more than 30 billion investment both in the port and in the free zone from different sectors. We're talking about petrochemical, food, pharmaceutical, steel, and logistics. And this is our strategy house. I won't go into details in this strategy house. But what I want to highlight here is the sustainability embedded in one of the strategic goals of Sohar Port and Free Zone, especially when it comes to attracting the high-tech and developing the high-tech industry within the port and in the free zone. Little facts and figures about the performance of the port and the free zone. Sohar port and free zone is one of the cornerstone of the Omani economy. We're talking about total employment, direct and indirect employment in the port, and the free zone is about 42,000 jobs. We're talking about 2.6% in contribution to the GDP of Oman. And we're talking about more than 75 million ton of throughput per year from the port. So what we are doing actually in Sohar port, we handle different type of cargo for import and export. When it comes to the export, Sohar port is representing around 80% of the total exported item and imported item to the Sultanate. We're talking about different type of terminals. We're talking about containers, dry bulk, liquid bulk, and food. We're providing the infrastructure for the Omani economy for the import and export and re-export as well. So, talking about the whole contribution to the Omani GDP, on the other hand, Sohar port also contributed, I would say, negatively to the environment as well, because we're talking about almost 24% from the total emission of the Sultanate is actually happened within a very small area, which is around 7.7 kilometers square only, which is really something we need to work hard to decarbonize and to do a lot in terms of also providing different type of solution to the tenants, the companies they are investing in the port and in the free zone. As you can see from the slide, we heavily depend on the gas. As my colleague yesterday mentioned also, that's the hydrogen, we have the experience of producing the hydrogen already in Oman. We're producing almost 5,000 K of gray hydrogen through SMR in Sohar port on a yearly basis. So that's a very good also opportunity to convey that from the gray hydrogen to a very low carbon also hydrogen using different type of technology, for example, electrolyzers and carbon capture as well. So I would really capitalize on what I've already mentioned in the last presentation, especially this in the last session, about also how we can decarbonize the port using the new technology when it comes to the hydrogen production, and how we can also use the Oman initiatives of producing green hydrogen in the south and bring it to the north in Sohar port as well. The gas consumption in Sohar port is mainly for three main reasons. One is to convert this gas to electricity, which take a huge portion of that gas. The second is to convert it into, use it during the process, so through the SMR. And the third is to produce steam for the process as well. So we have very good also opportunities to use renewables, producing electricity from solar parks, and spare the amount of gas using in the industry for another purpose. Taking you through the few numbers, this is from the National Hydrogen Strategy. I think it's clear to everyone in this room that Oman Vision 2050 to produce 8 million tons of green hydrogen, but down the road at 2030, the plan is to produce 1.3 million tons of green hydrogen from renewables, and that would require around almost 8 gigawatts of electrolyzers, plus 16 to 20 gigawatts of renewables. And that's also, if we go further down the road to 2040 and 2050, we would require around more than 100 gigawatts of renewables to be produced here locally in Oman. So what does it mean when it comes to the capacity installation and investments? If we're talking about the total requirement of more than 100 gigawatts of renewables, we will definitely need millions of solar panels. We will need definitely millions also of different type of components and supporting industries, started from concrete, steel, copper, aluminum, and silicon, and name it. So each one of these components also required a lot of efforts to bring. Definitely, the idea is not to import all of these components. We are not going to import 300 million of solar panels to support the local market. But the idea is to localize these industries. And this is what triggered us as Sohar Port and Free Zone. This is a very good opportunity to bring the international players, the international manufacturers as well, to produce this type of industries locally here in Oman and support the local market. So here we listed some of the industries that we are really focused on, and we actively engage with the international players to come and invest. And we have a very good offer and packaging for these industries as well. Started from the solar modules and electrolyzers, EV batteries, but also different type of lithium-ion batteries. We're talking about inverters, we're talking about membranes, and also the wind turbine. But definitely when it comes to the wind turbine, we are not talking about the whole components of the wind turbine, rather than the specific components, taking into account the geographic location of Sohar and how we can shift also these long blades from Sohar to the southern part of Oman. But we are looking to also localize the mechanical part of the wind turbine in Sohar. Actually, we started with the solar modules. And if we break down the solar modules, we have almost 6 different industries within the solar modules, started from the upstream industry, which is the polysilicon, down the road to produce also the solar module panels. But in between, we will need also to produce the ingots, wafers, and cells. When it comes to the battery storage, we started already this industry. We have already one company digging the ground, will produce the anode part of that lithium battery. And we have another one to produce the cathode parts. So we are in the process also to bring all these components under one umbrella to also create this ecosystem within Sohar. So yeah, this is what I'm talking about. The polysilicon projects in Sohar that's being built now is it's capable to produce up to 50 gigawatts of solar modules. That's already under construction. We expected the commercial operation by end of this year. We have also projects already signed in the solar cells, solar wafer ingots, and also we have 2 companies already signed to produce the solar panels in Sohar Free Zone. And this to support the local market, but also to export it to the international market. The big also success of this story is to establish the R&D center in Sohar, because of the nature of this type of business. The solar module business is really dynamic. It's every day new things happening in the market, so we need to capture that even and to build the local capabilities and capacities when it comes to workforce as well. All in all, to sum up what I have mentioned, I think we need the support from all stakeholders here in Oman to also work hard to localize this type of industries in Oman, instead of importing all the components from the international market. But we need to build this capacity within Oman to avoid any market, any logistics the disruption in the future. I think that's the end of my presentation. I'm really looking forward to have the panel discussion later on. And if you have any question, please feel free to ask later. Thank you so much.
Thanks, Engineer Haytham, for those valuable insights on building local supply chains for renewables in Oman. Up next, we have Mr. Jose Barragan Jimenez. Mr. Jose is the Vice President of Technical Services at Aqua Power, with over 20 years of experience in solar, wind, and energy storage technologies. Since joining Aqua Power in 2014, he has led the technical function for PV, wind, battery energy system, and CSP projects worldwide. Mr. Jose is an industrial engineer specialized in energy from University of Seville in Spain. He has also authored multiple publications and patents in solar energy. He will be presenting about world-leading hybrid solar power plant in commercial operation. Please join me in welcoming Mr. Jose.
Good afternoon, everyone. It's really my pleasure to be here. Thank you, Masih, for the introduction. Thank you all the organizers. Today, I'm going to talk a little bit about one project that Aqua Power developed, execute and operate today, in UAE. It's a hybrid solar power plant in commercial operation. The commercial operation started already last year for all the units. But today, I want to talk a little bit about the details about this project and how and why this project is a little bit unique in the solar industry, okay? Then, before starting with the project, I would like to talk a little bit about Aqua Power portfolio. Aqua Power is a developer, investor, and operator of a power plant and desalinated water project. Recently, we already incorporate also green gases in our portfolio. The company was founded in 2004 in the Kingdom of Saudi Arabia. At the beginning, we were developing water projects and combined cycle projects, mainly for power generation. But in 2011, we started our journey in renewables. We started with the concentrated solar power technology, CSP. That is going to be one of the main technologies I'm going to talk today under this project. Also, in 2015, we started to incorporate solar PV to our portfolio. Since that moment, we are starting to incorporate more and more installed capacity in renewables. And today, we can say that we have more than 56% of our portfolio are renewable projects. Then, Aqua Power is present in Oman also. We have several projects here. We have a good example also of PV technology with IEEE project, but also we have desalinated water in Salalah, Barka, and also power plants in Sohar and other. Then coming to the topic of my presentation today, I would like to start a little bit with the details about this hybrid project and why this project is something that maybe is very important to remark in the solar industry. First, this project is combining PV technology and CSP technology, concentrated solar power, and can operate 24 hours. Okay, we can dispatch energy during the day and during the night. We are using the PV to generate electricity directly to the grid with 250 megawatts and dispatched directly to the grid. And we have also CSP technology, 700 megawatts, that can operate during the day and during the night. Later on, we will see some record on how this project has been operating for a long period of time during the day and during the night. Another unique thing that we did in this project is the integration of the PV with the CSP. as PV technology is the lowest way to produce electricity today. We are using PV also to cover the auxiliary consumption of the CSP. Then we are providing during the day and connect some PV facilities to the auxiliary bus bar of the CSP plant. And then we are covering the auxiliary consumption that we have from the concentrated solar power with the PV. No? Then, this project is in UAE, and specifically in Dubai, is within Al Mantoun Solar Park. In Dubai is the phase 4 of the Al Mantoun Solar Park. As you can see the layout, we have different parabolic trough plants that I will talk a little bit more about this technology later. And we have also a central tower technology project. Then in the northeast, you can see the central tower plus some PV. The tower technology is we will see later some details about it. And then we have 3 parabolic trough projects, one in the northeast, the PT1, what we call PT1, parabolic trough 1, that is 200 megawatts. And then we have in the south part of the plot, within the same project, 2 units of parabolic trough 2 and parabolic trough 3, with 200 megawatts each, with 12 hours of storage. This storage is allowing us to produce electricity during the night also. The 3 parabolic troughs are identical projects and have exactly the same design, all the main components, everything is the same. Then you can see in the plot also some PV. As I mentioned before, we have 250 megawatt PV that is divided in 2 parts, 217 megawatts of full dispatch PV in the close to the area of the tower. And then we have also 33 megawatts in the plot of the PT3 in the east side of the plot, where we are having full dispatch to the grid directly. Apart of that, you can see another PV in the layout, this auxiliary PV. As I mentioned before, we are covering the parasitic consumption during the day for the CSP with this PV project. Then overall, it's an integrated project, 950 megawatts, that can operate during the day and during the night, providing electricity from CSP, 700 megawatts, and then 250 megawatts of PV. Then, as I mentioned before, the project is located in Al Mantoun Solar Park in Dubai, and the project is the phase 4. This project have been, at that time, a world record tariff also for the continuous operation for a solar hybrid project with 7.3 cents per kilowatt hour. And the rest of the phases that we can see in the Al Mantoun Solar Park are PV until today. And this is the only project that is incorporating also concentrated solar power to the solar park. Then the achievement, obviously, you know, we have different technologies here in this project and different phases, different kind of ways of producing electricity. Then all these phases are already in operation. We started with the photovoltaic full dispatch 1, 217 megawatts in commercial operation in December 2021. And then from there, we were having the commercial operation for the different phases, the parabolic trough 1, the central tower, and then the parabolic trough 3 and the photovoltaic full dispatch 33 megawatts were the last unit under operation under this project that start in February 2024. Okay, talking about the different technologies, as I mentioned, the project is very special for different reasons, because we can operate dispatchable energy during the day and during the night, but also because integrate different technologies, different ways to produce electricity. And we have central tower technology that is a project of, within the project is a unit that have 100 megawatts, okay, with 15 hours of storage. How this technology works, basically we have a solar field. The solar field is composed by mirrors. These mirrors are called heliostats that are reflecting the solar radiation, the concentrated solar radiation to the top of the tower. That is, the receiver is there. This receiver is like a boiler, open boiler, where we are heating a fluid. One fluid is called molten salt, is pumped up from the hot tank. You can see in the picture there are 2 tanks, one hot cold molten salt tank and one hot. Then we are pumping up from the cold molten salt tank to the receiver and then heating up the molten salt up to 565 degrees. And then the salts are going down to the hot tank. Then after that, what we are doing basically here is pumping the molten salt that are hot at 565 degrees through a steam generator system that is generating steam, and then we are going to a Rankine steam cycle, okay, generating electricity. Then, as we are storing the energy in the tank, we can produce at the same time that we are generating during the day, and also at the end of the day, when the solar radiation is not there anymore, we have the sunset, we continue the operation with the remaining salt that we have in the hot tank. Then with that, we are able to operate 24 hours. Then now we are going to go to the second concentrated solar power technology that we have in this project. This technology is called parabolic trough technology. As I mentioned before, we have 3 different units that are the same, 200 megawatt each, with 12 hours of storage, with 530 loops. The loops are composed by parabolic trough collector that we have per loop 4 collectors. And basically, the concept of this technology is we are heating through the solar field. In this case, we are concentrating the energy from the sun with mirror, parabolic trough mirror, in a pipe. This pipe is absorber tubes. And these absorber tubes, inside of the tubes, we have a thermal oil. This thermal oil is heated up from 300 degrees, 290 degrees, up to 390 degrees. Then this heated thermal oil is going to a steam generator system where we are generating steam, and basically we are generating electricity with a steam turbine. Then at the same time, the excess of energy that we are collecting from the solar field is going to the storage system, and we are storing this energy through molten salts, similar with the tower, but in this case we are exchanging the energy from the thermal oil to the molten salt. Then the project structure is basically we have a project company. We have different shareholders, EPC contractor, and then power purchase agreement for 35 years. And then the owner company is NOMAC, that is 100% Aqua Power. Okay? Then some facts of the project, very quickly. The project is a very large project. I like always to use this example. No, the project is 44 square kilometers. It's equivalent to 6,200 football stadium. No? And the total cost of the project is $4.3 billion. Then EPC Electric was Shanghai Electric, EPC contractor for this project, accumulating more than 64.7 million hours. The project has some world record, you know. It's the tallest tower in the world for this technology, the largest storage capacity with 570,000 tons of molten salt, and also for the parabolic trough, we have also the highest capacity. Then we have also, in a single project, 700 megawatts CSP. This is the largest also of the world. The solar field of each unit is the largest in the world, and we already accomplished more than 40 days of continuous operation for a CSP project. That is also another world record. Then go faster, because of limit of the time. Obviously, in this kind of project, we are bringing value for the local countries. This is important to take into consideration that with this technology we are bringing a lot of value. Here's an example of the value created in Saudi, in UAE. And then to finalize, and before going to also a short video of the construction of the project, you can see here in this slide 2 days of operation, one with the city unit, the central tower, another with the parabolic trough. And you see how we are operating 24 hours. The blue line is gross power, red line is net power dispatched to the grid, where you are going to, and the green is representing the storage that we are filling during the day and then discharging during the night to continue the operation. Okay? These 2 days are an example of sunny days, but are real data, actual data of the project. Okay? Then, just to summarize, the project is a very unique project and has several world records. As I mentioned before, largest CSP project in the world, largest solar field for each parabolic trough units. Also, we have the largest storage, largest size of the collector for the parabolic trough. At the same time, we are also having the tallest tower in the world for this technology and the largest solar field for the tower. Then we are going to go now to show a brief video about the construction of the project. I hope you enjoy with it. Thank you. Thank you.
Thank you, Jose, for sharing this fascinating case of solar hybrid power in action. Our next speaker is Ms. Raya Al-Wahabi. She is a senior project engineer at Nama Power and Water Procurement, PWP. She holds a bachelor degrees in mechatronic engineering from Sultan Qaboos University, and she is currently pursuing an MBA in energy and sustainability in Spain. Ms. Raya has contributed significantly to utility-scale renewable projects, including wind power initiatives, supporting Oman's clean energy transition. She will be presenting about combining wind power with solar PV to improve the grid stability, case study of Duqm here in Oman. Please join me in welcoming Ms. Raya to the stage.
Assalamu alaikum, everyone. Good afternoon. Am I audible? Am I audible? Okay, thank you. Assalamu alaikum, everyone. Good afternoon. So thank you, Dr. Mazen, for the kind introduction, which will save me one slide in my presentation. And just a disclaimer, my presentation is will be very technical. It's a case study that manifesting Duqm, which is in relation to combining wind power with solar PV to improve grid stability. So kindly bear with me, and it's in my capacity as a researcher, not representing the outcomes from PWP. It's just an initiative that I took. So just for the sake of time, I'll be skipping some of the slides, but I'll promise I'll cover everything related, the most important things. So throughout this presentation, I'll take you through the problem statement and a background. Why I selected DACM for this case study, and what are the constraints related to combining wind and solar PV, layout optimization and the analysis findings from the simulation that I have done, and finally the findings and the conclusion. So on Oman renewable energy roadmap, so some people will think that renewable energy is something new to Oman, but believe me, it's not. We have multiple initiatives that started back in 2008, where Oman was planning to integrate some solar projects as part of the plans. However, at that time, it was very expensive and it was not economic. However, during that period, we continued to do researches, we continued to monitor the progress in the technologies and collecting data as well, on-ground data. In 2017, the first fuel diversification policy was established. The target was to achieve 10% of renewables by 2025. And some of the first targets that we have, or achievements that we have completed. So in 2019, we had our first wind project operational. The project was signed in 2017. And it's currently our only operational wind plant, but it will be followed by multiple wind projects across Oman. In 2021, we had our largest solar plant became operational, which is Abri 2 for 500 megawatts. So in terms of targets, we have to achieve 30% by 2030 and 60% by 2040. All these percentages should come from renewable energy. And by 2050, we have to meet our target to achieve net zero. So how can we achieve this ambitious targets and in terms of the renewable targets as well as decarbonization? So we have to minimize, and it cannot be done that we will get rid of our thermal plants and gas-fired plants. So we have to minimize the use of it, as well as we deploy more of the renewable energy, and massive amount of those investments will be in PV and wind for the reasons which I'll explain, and also investigate number of storage options. So if we speak about the solar energy, we can, this map shows you the potential in Oman. So the darker the color gets, the higher the potential of renewable, the solar energy. So we can see that the color gets darker toward the south of Oman, while the load is concentrated toward the north of Oman. We have a higher potential than most of the countries around the world when it comes to solar energy. And that's, and if we speak about numbers, we have around, we call it the global horizontal radiation, GHI, which ranges from 2,000 to 2,500. And in terms of the wind energy, similarly, we have multiple sites in Oman which has a very high wind potential, and most of them are concentrated towards the coastal of Oman. So and similar to solar, these sites are located toward the south. However, we've been lucky that we have the interconnection, the 400 kV line, which will connect the south of Oman and the north of Oman, which will enable more of renewable energies to be deployed. So from this map, we can see that the best sites for wind are toward Dhofar and Tamret. Then we have Duqm, as well as number of sites in Sharqiya region, such as Ja'lan Bani Bu Ali. We had the first plant in 2019, 50 megawatts, located in Harwil. So what is the issue with that? So we had Oman and the GCC as well as globally. We've been seeing a lot of projects that are being promised, being Already some of them are operational and some are on the pipeline, but most of them are in standalone basis. When we do this standalone basis, either wind or solar, that would mean that we are producing, our output will be fluctuating. That would create a stress on the grid by having the frequency and voltage controls issues, as well as issues related to the reserve needs and increasing our reserve needs and costs. So if we combine both of them, there is a potential that we will be having a smoother output, we'll be reducing our ramp rates and optimizing the grid infrastructure. So this will eventually support our Oman targets to achieve our targets, as well as safeguarding the system reliability. So this graph shows the dispatch profile. The first one is related to the solar PV. It's 300 megawatts of PV. We can see that the dispatch will start around 6, and then it will end around 6 as well, evening. And the next graph, the lower one, it's the 300 megawatts of wind. It also shows a huge fluctuation in the daily dispatch, which is not something that you would entertain in a grid, because we need a reliable, as the users, we need a reliable energy that's constantly throughout the day. So how can we get, I would say, like a smoother output and that can run throughout the day? So here's the issue with the standalone wind or solar. We'll be having fluctuating outputs and intermittency, which means that our plant, if it's solar, if it's cloudy throughout the day, we will be, the plant will be fluctuating in terms of output, and we will be losing some of the output. This will lead to, this is going to lead to losing the output, as well as having higher spinning reserves. And also there will be a potential curtailment throughout the operation of these plants. So hybrid generation plants is not something new, and it's been done in multiple countries. And I've been looking into those projects around the world that has deployed 2 or more technologies, and you can see here a pattern that those projects are small scale. While we can debate it on how can we put a threshold on what's a utility scale, but these would consider as a small, except for the project, lastly, which is the India projects, and I'll come to explain why is it a large-scale project. I'll skip this, but I'll come to it towards the case study. So just to save time, I'll start by introducing the case study. So you can see from these 2 maps why Duqm is selected. So the darker the color gets, it means that we have a higher potential, and this can be done if we choose a site which is in Duqm. Not only because of the availability of the resources of solar and wind, but also that Duqm is a growing industrial hub, which means that we will be closer to the demand. So whenever we select a site, we make sure that it's close to the demand, so we don't necessarily transmit the electricity to higher distances. Also, it's somewhere between the north and south, and there are flat areas and developed areas which are suitable for the large-scale utility, as well as access to roads. So if you've been to Duqm, you will see that it's well planned, and you have plenty of access road, which make it easier to build plants in there. Also, availability of the connection, the 400 kV from OITC, as well as the availability of the wind resource data, as well as the solar data, which is very important for any project. So in terms of the wind resource data, unlike the solar, when you are developing a wind project, you must have an on-ground data for wind, which make it a bottleneck for the development of wind for the reasons I'll be explaining. However, just this slide will show you where to get the data if you're interested in doing any researches or planning to do projects in Oman. So there are multiple sources that you can get the data from. So for DOCOM, the data is publicly available. And when we say publicly, what is the threshold for the data? So as per the standards, we need 12 months, consecutive months of data collection to be done. As well as we have also associated with the wind resource assessment that has been done for DOCOM, we have also the solar radiations. So the publicly available sites data are 3 sites. We have one toward the north and close to the port, 2 toward the sites, and they are adjacent to each other. So I've done a matrix that can select among those sites which one. So the matrix is depending, it has a various criteria to summarize them: the wind speed, solar irradiations, proximity from the port, site terrain, grid proximity, and load proximity as well. So I landed on using the first site. You can clearly see that it's very near to the port, which means that the equipment will be delivered very easily, because if you have not witnessed the wind transportation, it really transport the very large equipment. So you need it to be either ports or to have very clear and very clear roads. So in terms of data, we can see that this is the wind average. It ranges from 5 to 9 and mostly above 8. And the average throughout the year is 8. And when it comes to the windrows, which is very, very important to be accounted when designing wind plants, we can see that the wind is blowing from the southwest, as well as the solar irradiations. We have a very high solar irradiation. So for a solar plant, you will need to have a range of 700 to 1,000. You can see that it's higher for our site. So in terms of assumptions that I took while doing this case study, I assume that we have a land of 50 kilometers square, which is an area to 7 by 7. The shape of the area is very important, and I assume that it's a square shape, while this is not happening in most of the cases, and a flat terrain. If we don't have a flat terrain, it's not possible to adopt the hybrid generation. Not only the hybrid generation, a solar PV plant cannot be allocated in a hilly area or a mountain area, areas with wadis, for example. So we need a very flat terrain in order to make a solar plant or a hybrid plant in this case. So when utilizing 25% of the land, we will be having a plant of 800 to 900 megawatts of solar energy. And for the wind, it will be ranging from 290 up to 380. So the consideration have been taken into account when doing the study is that I took into account 6.5 megawatts turbines, which are commercially available. However, today we are speaking about 9 and 10 megawatts. However, I chose to be conservative on this analysis. Also, central inverters has been selected for the optimization of the cabling, and there are a number of spacing consideration to be taken into account when designing a hybrid plant. For example, you have to take the wake effect between each wind turbine, as well as to take into account the shading that the turbines will be making to those panels. Also, there are special considerations for the road crane movement and during construction and O&M. Unlike when you're doing solar, you have to account for larger buffers. as well as the cabling optimization. So this what would a wind plant look like if we are only utilizing a wind technology. So just a remark, this is, when I've been doing the site study, I considered that this is a high potential wind site. So it will be, the basis will be that I'll be filling the site first by wind, and then among those, I'll be putting my PV solars. So in terms of spacing, we will be having 5x7, which is the requirement from the IEEE standards. So that means that we will be having 0.8, if you can see here, 0.8 across the wind, because the wind is blowing from the south of the site, and perpendicular will have 1.2. Additional considerations we will go through is the first one is the shading. So how can, just to understand what is the, what would create a shading? So the tower itself will be having a shading effect, and that's what we call shadow flicker. However, this shadow flicker, it will appear on the days that are in the morning and in the evening, or the sunrise. This when the shadow flicker will be happening. So the effect of it will be minimal, and to design a plant, we have an acceptable range of how much the shadow is, because the shadow itself will create an issue with the panels. So if you imagine if you're having a one solar panel, half of it is affected by the shadow and half of it is not. That means you will be having a non-uniform current, which will mean that you'll be having hotspots, and that would reduce the lifetime of your plant. So in summary, the buffer zone is 250 meters. It's safer to go beyond and select 500, but that would eat from your site. While modeling, this would result around 1 to 2% of losses on an annual basis. In terms of the grid infrastructure, if we have a hybrid plant, that means we will be having a common infrastructure for the grid. That would lower the capex around 20 to 30% from the grid side. That would reduce as well the land footprint that we will be needing, as well as improve the utilization of the transmission corridors. However, that is not yet proven to be practical, and it's not tested that we can operate a hybrid plant without any issues, because each of the technologies will have its own frequency issues, its own control issues. In terms of other considerations, access corridors, crane movement, drainage, this has been taken into account, as well as the zoning of the PV arrays. So in PV, we can, in 1 kilometer, fit around 30 megawatts. However, due to the conservative of fitting hybrid generation, 30 megawatts will be fitted in 3.1 kilometers square, because we will be taking into account the other aspects and respecting the other buffers, which will mean that we will result in 16 blocks of PV solars, which is around 480 megawatts. So in total, 480 megawatts of solar will be combined with 50 turbines, each 6.5, which is total of 250 megawatts, and the total of the plant is 805 megawatts. So this would the dispatch be in a typical day in July. You can see that you can dispatch throughout the day. The PV solar will be from 6 to 6, and throughout the day you have a complementary output of wind. So I'll quickly go through the challenges. So it's not that we are creating something new by introducing the hybrid generation, but why hybrid generation has not been implemented until now? There are a lot of challenges, and mainly on the financing. The lenders will be skeptical about lending two technologies in one project, because it means that they have a higher risk. Also, we don't have PPAs, and trust me, this is very, it's a very serious matter that we don't have yet a PPAs that accommodate for hybrid generation, as well as we don't have a regulatory framework for hybrid generation. Also, the grid codes should be updated to allow for hybrid generation, as well as until now, until recently, solar PV was very economic, that we didn't need to study hybrid generation. We didn't need, in some places, we didn't need even the wind. However, today, with the accelerating demand that we foresee, we are looking into other aspects besides the hybrid generation as well. Also, there are advancements in a lot of aspects, which are the controller, hybrid SCADA as well. Grid forming inverters are getting mature, which will enable the hybrid generation. There are considerations to be taken in place. So if we recall the last year sessions, we were not discussing RTCs, which is round the clock. However, this year, everywhere we go, the hot topic is the round the clock. So it's evolving. Best technologies as well, the batteries are evolving, grid forming inverters and hybrid generation PPAs as well are evolving. So in conclusion, this case study proves that it's possible technically to co-locate the solar PV and the wind as well. It's not only that it will achieve the grid benefits, it would be advantageous for the whole grid in terms of the output, in terms of the frequency and the controls. However, we will need the right policies. We will need a structured PPAs, as well as we need to update our grid codes to be in alignment and allow this to happen. By doing such, we will be having DOCOM as a regional benchmark for hybrid generation, and nearly we can achieve an RTC even without BESS in some cases. Thank you very much.
Thank you, Thuraya, for highlighting the importance of hybridization in enhancing grid stability. Our next speaker is Mr. Saravanan Jagannathan. He is a Hub Product Marketing Manager for Power Quality Products at Hitachi Energy, based in Dubai, covering Middle East and Africa region. He has over 24 years of experience in marketing and sales of power quality solutions across various global markets. He holds a bachelor's degree in electrical and electronics engineering from Madurai Kamraj University in India. His expertise includes power quality in utility, industrial, commercial, railway, and renewable sectors, with a focus on power quality studies and filter bank design. He will be presenting on hybrid compensation solutions for renewable segment. Please join me in welcoming Mr. Saravanan to the stage. All the best.
PowerTalks. Good afternoon. After a heavy lunch, I think we feel a little bit downside. So let me try my best. First of all, thank you very much for such introduction, and thank you very much IEEE PowerTalks for giving me this opportunity. I think this is the second time. Last time I was covering on the overall power quality challenges with the renewable integrations. Okay. This time I'm going into the little bit details on how the harmonic separation is important, especially the higher order harmonics. The hybrid, from the word itself, it is combining two technologies, both active as well as passive technology. How it maintains the power quality going forward. Active technology, as we know that all kind of power electronic devices, IGBT-based voltage source converter technology like STATCOM, It can able to provide dynamic reactive power support and maintain the voltage stability. Very expensive, but very good technology as well. But the passive on the other side, it composed of passive components like RLC. As per IEEE 61642, the combination of these components forming a harmonic filter bank to suppress the harmonics and maintain the power quality. But at the same time, it can able to provide the consistent fixed reactive power support. So both these technology going forward, how it will address the power quality issues going forward. And this is about my total agenda. I am going to end up with some kind of real-time case study, simulation reports. I didn't put a lot of things into this presentation. If you need more details on the simulation report, we can discuss separately and we can provide it, how this conclusion was made. Not only on the theoretical part, it is actually on the real-time case study was done before this paper. Thanks to my previous speaker, and she was showing the roadmap, this 30% of renewable contribution by 2030, and 60% I remember by 2040, and 100% by 2050, which is really good. Net zero impact. So by 2050, you are totally going with 100% renewable generation in terms of sustainability, and because renewables are most cost competitiveness. And of course, we started producing green electricity, and it will improve green economy as well. And so the problem is we started removing synchronous generator. Trump used to say that it's a rotating equipment. So the rotating equipment is going out of the circuit, means we are losing the inertia. So we are the stability, and we have been very much successful in managing the synchronous generator for the last over many years. And we are now going to replace it with some kind of power electronic based generations that is going to introduce more and more level of electronics. And because of this variable and intermittent in nature, we are going with battery energy storage system, which is of course is needed. So in an electrical network, whenever there is a power conversion is taking place, AC to DC or DC to AC, if we need a power electronic device, again it will introduce more and more complexity in terms of harmonics and resonance. The main important thing is resonance, which further amplifies our problem. So this is about the general about these, the challenges on the renewable integration to our grid. So then we need to upgrade the grid code compliance. We should not live in the old standard, which is operating in asynchronous generator. So the new grid code norms must be in place. So I request the policy holders that most of the countries, they started upgrading, considering the renewable addition into the grid. In terms of frequency and voltage stability, I think most of the countries, they are covering fair enough on the how to maintain in these two parameters. But most of the time, some of the countries in the Middle East and Africa, they are not much focusing on the harmonic side. Why it is important is the power electronic devices, not only on the demand side. You see, I'm seeing a lot of power electronic devices, computers, fax machines, all these energy saving lamps. In addition to that, we also introduced all these power electronic devices in each and every electrical value chain, generation side, solar inverters and wind power converters. On the transmission side, we are going with HVDC, again power electronic devices, BESS, again power electronic devices. So now we are seeing overall the power electronic devices, which is very much inevitable. So then the thing is, the side effect must be addressed. And the previous standard is only talking about 50th order. So it must be upgraded to the 100th order. Thanks to some of the countries in Middle East, they already did this upgradation. And they are also insisting for a sophisticated tool, the power simulation software, which can address impedance locate. Now the grid impedance and the grid harmonics also must be taken into an account for doing the simulations in software. So that also must be upgraded. And just for the voltage stability, we must talk about the reactive power capability. So since we have been successful in managing the reactive power capability of a synchronous generator, we know that it is a D-curve capability. It is not like a transformer, it's a circular capability. We cannot inject 0% active power and 100% reactive power. Transformer can do it, because it is a different device, even though it is an inductive load. But in a generator, we have a limitation. We should operate the generator at minimum less than 20% of the capacity. So considering the alternator capacity, the rotor current limit, and the thermal stability limit, that's why the stability curve is more important. Even though some kind of complexity in operating synchronous generator, we were managing it very well for n number of years. But going forward, the solar inverters are having a different capability. It is an inverter, and inverters are designed in apparent current. And apparent current is nothing but the vectorial sum of active plus reactive current. If the IPPs, they wanted to produce more and more active power, kilowatt hour, which they are signing the contract with the grid operators, then these inverters are capable to produce more active power to generate more revenue. Even though nowadays all these latest inverters are having the capability to produce reactive power within itself at the inverter terminal, but the performance measured in at the point of interconnections. And thanks to the grid core norms, at least they are mentioning plus 0.95 to minus 0.95 power factor. All these inverters should be capable to inject reactive power. That's why the 0.95 to minus 0.95 means it is 33% of the inverter capacity. It should be capable to supply the reactive power at the inverter terminal. Okay? And it should pause, in the simulation study, we usually do these PQ, QE simulations and then voltage simulation study in ETAP, PSCAD, Dixel, and Power Factory to understand how much reactive power externally is needed to maintain the voltage stability at the point of connections. So the reactive power is important. At the same time, the harmonics is also important, which is used to describe the characteristic of a waveform. All the solar inverters, it produces current harmonics. Okay. Oh, sorry. Because each and every waveform is different, and mathematically it is multiple of the fundamental frequency. And here, you see up to 5th, 7th, is mainly you can see in the demand side. There's all these single-phase nonlinear loads which produces third harmonic as predominant. Why I mentioned about 13, 25, even the 49th harmonic is all our solar inverters and wind power converters, when it is combining with the reactance of the network, it will amplify these higher order harmonics. So which must be taken care into and addressed. And the voltage harmonics, it's a very simple logic. It is an ohmic law. So more current harmonics with respect to the impedance of the network, the voltage profile is getting distorted, and the same voltage profile is supplying to more consumers. So the voltage harmonics and the current harmonic must be maintained in the new grid code norms. Voltage is very easy to define the voltage limit according to the voltage category. So if it is at the point of connection is 132 kV, obviously it should be maintained less than 1.5%, and individual order should be maintained less than 1%. But for the current harmonics, IEEE 519 clearly states that ISE by IL. We should follow that. I think it is fairly covering the current harmonic limit, and the overall THD is 1.5, and then individual is 1%. So the harmonic regulations we are talking about, even in UK, they are going for G54 will be replaced by G55 up to 100th harmonic. Even Saudi also, they are following more or less the same grid code norms, the harmonics up to 100th order, because, and also they are considering the interharmonic as well. Oh, 10 minutes over. I'm sorry. Oh, 5 minutes left. Okay. Okay, the resonance, why the resonance is important is, it is very much important for the power electronic based interfaces. Resonance is good or bad from your experience. It's always good. For a fundamental frequency network, XL is equal to XC means it's ideal network. The power factor is unity. But in case of harmonic rich environment, I think it is really bad. This resonance is creating more and more amplification of harmonics at the point of interconnection. I don't want to go into details due to the time. I will conclude with, this slide is very much important for any solar inverters or wind power converters, I think we must do frequency versus impedance analysis to understand the harmonic pattern. Thanks to the technology, all the latest inverters, they produce harmonics 1%, 2%, 3%. In the data sheet, you can see the attractive picture within the limit at the inverter level. But the problem is when it is operating under different generating conditions, my previous speaker was also showing the curve, how it is varying from 100 megawatt hour to 600 megawatt hour, and then it is coming down. So when it is operating under different conditions, low load conditions, the percentage of harmonics will be higher. And when it is combined with the system impedance and the system reactance, you are seeing the amplification in the higher order. 13th, you see the first amplification, a slight amplification, and then you can see also the 25th, the extreme amplification. The impedance is so high, even the 1% of harmonics produced at the inverter level multiply by this huge value of the ohmic value, and it will result into 14 to 17% of the voltage harmonic, which is abnormally higher. The voltage harmonic, it will damage any kind of electrical equipment, including the strong equipment like a transformer. Imagine that. We are talking about 1% or 1.5% at the point of interconnections, but it will result into 14 to 17%. And the other one is, if you also see the frequency versus impedance curve, a lot of amplification. The highest limit is 3 times of the harmonic impedance. The lowest limit is the system impedance. So it is always more than the value. The impedance versus frequency, if you plot, obviously a lot of amplification on the higher order. Okay? And this is a real-time case study. I think I will conclude with this case study. We took one of the 300 megawatt solar power plant, and the point of interconnection is 132 kV side. And when we do the simulation about the reactive power requirement, since the inverters can able to also take care of some kind of reactive power within inverter itself, the external reactive power required for this network it varies from 120 megawatt. Injection means the capacitive reactive power, and the inductive reactive power is only up to 30 megawatt. Then why we are going for a STATCOM equal rating, 120 megawatt? It's a waste of money and economically, of course, but it is not needed. We are underutilizing our assets actually. So when both the capacitive and inductive reactive power are same, then 120 plus or minus 120 megawatt makes sense. When there is a lower inductive reactive power requirement, then we can also think about this kind of hybrid compensation of putting some fixed compensation plus STATCOM. It will address both dynamic reactive power as well as the harmonic separation. And the one more limitation of any STATCOM is it cannot address 25th order or 49th order harmonics. It is much more efficient up to 11th order harmonics. That is the limitation. So that will be offset by this kind of passive detuned filter or tuned filter. There are different types of filter, which I don't want to go through it, but if you see here in this real-time case study, this is a harmonic spectrum, second order up to 50th order. You see there is the red dotted mark. You can see the amplification of harmonics, 13, 25, 27, 29, and 49th order. Both voltage and current harmonics are on the above the limit, and it has resulted into 14 to 17%. And the bandpass filter is always good if you are going for a lower order like 5th and 7th. Otherwise, the damped filter, if you are directly going for a designing higher order harmonic filter like 25th order, or 19th order, or 49th order, we must go for a damped filter. Otherwise, it will result into the amplification of the lower order harmonic. So the C filters as well as high pass filters is good for any kind of network which can able to address the higher order harmonics. We are damping it. The circuit itself will say that the resistor is across the reactor. And if you see the impedance versus frequency curve, the damped filters, there is no amplification at all at the green color, the down actually. The remaining other capacitors and other filters, it shows some amplification. This is after installation of the filter bank. All the individual order as well as the total harmonic distortion is within the limit. In both steady state condition as well as dynamic conditions, this hybrid compensation, it can able to meet the voltage stability, dynamic reactive power component, as well as the harmonic suppression each and every individual order. In a steady state condition, no problem. But in the dynamic conditions, here the STATCOM plays an important role. We need a dynamic reactive power compensation like STATCOM. In addition to that, nowadays the modern inverters are coming up with the voltage right-through capabilities. Combining with this filter bank of higher order, then we can able to even meet the dynamic condition analysis. In case if these filters can be brought into the circuit, we can also design a faster discharge circuit. Within one cycle of 20 milliseconds, we can brought back this filter and again switched on. So from Hitachi Energy side, we have all types of solutions. We have capacitors, a conventional reactive power support. We have automatic power factor system and harmonic filter bank. We have SVC, we have STATCOM, and we also have hybrid compensation combining with this higher order harmonic suitable for renewable segment. And we are not only a product supplier, and this kind of renewables which needs to start with the study, grid code compliance study, we can also support our customers by providing the simulation results and recommending suitable solution to our customers. And we have good success stories in Europe, Middle East and Africa. We have a number of renewables in UAE, Saudi, and of course in Oman also we have reference. I need to check with our sales colleagues. We have a number of good case studies. Due to time, I am not going in detail. So the conclusion is the grid code norms needs to be updated as per the renewable integration into the circuit. And the technology-wise, hybrid is the best superior for going forward to meet the dynamic, reactive, and harmonic suppression. And Hitachi Energy is a solution provider for this application, being a technology and market leader. Thank you very much.
Thank you, Sarvanan, for a very informative presentation about hybrid compensation solutions. We had so far 3 hybrid presentations. All of them were great. Our next speaker is Mr. Peter. Mr. Peter Stiles, he is chairman of the supervisory board of the energy company of Ukraine and executive advisory to the Zero Emission Trades Alliance. He founded Stratos European Policy and Stratos Energy Consulting, advising on energy transition, carbon markets, and EU energy policy. Peter has served on the board of the European Federation of Energy Traders for over 2 decades, and he is an honorary lecturer at Dundee University, specialized in energy, petroleum, and minerals law. He will talk about the integration of renewables, generation sources, and harnessing the market. Join me to welcome Mr. Peter. The floor is yours.
Thank you for this very nice introduction. An apology initially. My voice is going, as you can hear. I think I caught a bug on the plane across to the Gulf, and it's gone straight to my throat. So I hope if I throw my voice forward, I am comprehensible. What I want to talk about today, briefly, is where I left off yesterday, really, when I was talking about design for the wholesale power market. So, assuming that a wholesale market is in operation in some way, either nationally or regionally, the question then becomes how best to integrate renewable generation sources in that market, and how, furthermore, to harness market mechanisms beyond even the functioning of the wholesale electricity market in order to give efficient price signals and efficient investment signals. So the traditional way of providing some financial support to renewable electricity throughout the world so far really has been various mixes of investment grants, power purchase agreements, and fixed feed-in tariffs. These are the mechanisms which states typically start with in order to get the transition to renewable electricity underway. I see the disadvantage with investment grants and state procurement using PPAs, which I know is the predominant way this has been done in Oman so far, being that they don't really bring a guarantee of reliable output, and they produce a risk of either excessive cost to the state or windfall profits to the developer, or maybe both. And it's simple, but it's really hard to forecast 15, or in some cases can be 20, 30 years in advance. I think for the concentrated solar in Dubai, we heard 35 years. It's really difficult to forecast what is a reasonable long-term wholesale price over that period, I would suggest. And then when it comes to fixed feed-in tariffs, again, they're simple, but they tend to work out to be very expensive also. And they're, by definition, because they're fixed, they're not flexible. They usually require a very strong regime of dispatch priority for renewable generators. And essentially, if you do have a power market in operation, or you aspire to do so, these tariffs are, of course, unrelated to market prices, unlike the alternatives in terms of contractual remuneration of feed-in premiums, that's a premium to the market price, or a contract for differences, which relies on calculation according to daily spot market outcomes. So examples of countries that have initially adopted fixed feed-in tariffs and then found that they really needed to abandon them for reasons of cost predominantly. We have Germany between about 2000 and 2010, Australia from about 2008 to 2013, and China from 2010, but with an apparent intention to get rid of these tariffs or stop granting them at least by the end of this year. The privileges that go with fixed feed-in tariffs and tend to go, of course, with PPA or grant remuneration as well, are that TSOs are obliged by regulatory mechanisms to place renewable electricity at the top of the schedule. They're forced to minimize curtailment of renewable output, and renewable electricity generators are given preferential treatment in terms of connection or transmission grid constraints, where renewable generators then would typically retain their transmission rights, even if others have lost them. And I think the problems with this are that over time, as the market matures, priority dispatch tends to impede the visibility of power price formation, reduces the efficiency of the overall wholesale power market functioning, and priority access to the grid may be costly in terms of connection preferences, and it may impair efficient use of constrained grid capacity. So here's an alternative. It may be too soon to think about this in the Gulf, but it might fit with the evolution of a more transparent and more liquid wholesale power market. It's using a market mechanism to incentivize the rollout of renewable energy. So retail suppliers under a supply, quota, and certification scheme are given a quota. This applies to all suppliers, whether it's a monopoly supplier or those competing with each other. they're given a quota of a minimum volume of their supply to customers that must come from renewable sources. They then prove a renewable generation source by purchasing guarantees of origin from renewable generators. These guarantees of origin, these are not voluntary, these are compulsory, may be then sold and bought in a secondary market to allow each supplier to fulfill its quota or its benefit, or to benefit from a surplus. And this can work, I think, whether there is vertical integration in generation and supply or disaggregation. It can work even in a single buyer system, as long as the regulator or government sets the quota realistically, and as long as the secondary market is allowed to function unimpeded. Countries which have adopted this in Europe at various stages have included Britain, Sweden, Poland, Italy, and Belgium. And the Swedish scheme has proved one of the most successful and is relied on to this day. In Germany, they've not gone for a supply quota and certificate scheme, but they have benefited from quite some extra revenue coming from guarantees of origin in a voluntary market. And you can see here the figures have become quite impressively large over time, going from less than 4 gigawatts in the 2010s to over 16 gigawatts of supply, where subsidies have partially been replaced by these voluntary certificates in the form of a voluntary market in GOOs. It doesn't work in all countries. It only works where a lot of consumers really want renewable power rather than traditional source power. But the value has gone up to some few euros per megawatt hour in some European countries from what used to be a typical rate of 0.5 or 0.7 per megawatt hour. So here's a summary chart, which maybe I'm not going to go through now, but you can look at when you get the slides. It's a kind of summary of how market interventions and market-based mechanisms fit within the panoply of help that can be given to renewable energy generators. And you see other types of intervention, some of which we've heard about in this session: technical, engineering, optimization of networks, use of storage, and so on, all the sort of engineering and network-related improvements and reforms. I would include in that changes to grid codes, but also we have market types of interventions, creation of markets in instruments, the type of thing I've been talking about, like a quota and certificate scheme, which on the basis of how much they cost and how much benefit they bring, you can see from the low positioning in the chart, can be pretty cost effective. This was research done for the International Renewables Association, IRENA. Now, I should mention, when I'm talking about market-based mechanisms, the wisdom, I would say the gold standard, of introducing in parallel to a functioning liquid competitive wholesale power market and using market mechanisms to help incentivize renewable investment and output, the benefit of having in parallel a carbon emissions cap and trade scheme. You know what this is, I think most of you will know. Most of you will know about the European Union emissions trading system. So I won't run through all of these steps, But suffice it to say, as the screw is tightened and the cap on emissions in a particular sector goes down, then the imperative to reduce carbon emissions, and in the power sector, that effectively means maximizing the transition to non-fossil fuels, becomes ever greater. And this has been really important in Europe. I think it's becoming important in countries like China and Korea. It's becoming important in California. It's being now rolled out to other sectors, not just power generation and heavy industry, but even into transport and even into building, heating of buildings and heating of water. It's really difficult to have a policy decision to put one in place. I think it would be great if it were put in place across the GCC. I think it would bring all sorts of benefits: inward investment, confidence in market signals, confidence in the reliance on the market, and willingness to see competition and inward penetration of the market. And this is, again, a slide you can study at your own leisure when you get the slides, but it's just a summary from a ZETA point of view, Zero Emissions Traders Alliance, how there can eventually be an interaction of all of these markets. So again, assuming you have a competitive, liquid, wholesale power market, then you can go on to have markets in carbon credits, renewable certificates, zero carbon emission products, green biogas products, and it's a kind of mixture of trading in the commodity on the one hand and the attributes which are wanted by the policymakers and accepted by consumers, the green and low carbon attributes through a range of contracts and products. So this is a little encapsulation of the ZETA vision of how this could work. So our ideas for you: think about using more market-based mechanisms in Oman. Investigate the feasibility of introducing a renewable electricity generation quota and supply certificate scheme, preferably across the GCC, or at least other market-based mechanisms like feed-in premia or contracts for differences would be alternatives. And start regional discussions about the merit and benefit of a carbon emissions cap and trade scheme, which would so well complement and help underpin market-based retail electricity pricing, and, I suggest, underpin a transition to renewable and low-carbon sources. Thanks for your attention. The rest is about ZETA. Again, you've seen that, and you can see it in the slide back. I look forward to any questions.
Thank you, Peter, for that powerful presentation. Indeed, we need to harness the market. Our last speaker is Mr. Walid Al-Washahi. Mr. Walid Al-Washahi, he is a renewable energy engineer in Petroleum Development Oman, PDO. He is specializing in utility-scale wind and hybrid power systems. With over 8 years of experience in the power sector, he has worked across gas turbines operations and renewable project management. At Petroleum Development Oman, he has played a key role in advancing the company's energy transition, including leading the 100 megawatts Riyah 2 wind farm. He holds a master's degree in electrical energy system from Cardiff University, UK. Please join me to welcome Walid Washahi to the stage. Walid, the floor is yours.
Assalamu alaikum, everyone. Thanks, Dr. Mazen, for the nice introduction. It's really nice to be here at the IEEE, although I've been put till the last presentation, which I hope you guys have the energy to comprehend all that we'll be talking about. So without further ado, I'll just get right into the subject that I'm going to talk to you about. It would be about the 3 IBBs that PDO has recently awarded, which is the solar and wind projects. So as the agenda, I've split the talk into 4 main areas. I'll start off by giving a background about the PDO power system. Then I'll move on to talk about the power generation and PDO, the split that we have. And I'll move from there to the power system strategy and where are we sitting and where are we heading from there. Then I'll dive into the main topic of today, which is the 3 IBB projects. So as a start, PDO power system, we all know PDO here, I hope. Petroleum Development Oman. It's the largest oil and gas producer in the country. We produce the majority of oil and gas with all the complications that are coming into it, which is the EOR, where we enhance the recovery of the oil through all of the other facilities, and where the power system just is fit into that. As you guys know, we have a total installed capacity of over 1.5 gigawatt. I have all the details of the generation units and the power stations, as well as the substations and the OHL network. As you can see, the power network extends or stretches over the entire country. And we have, in terms of 33 kV OHL network, it's over 30,000 kilometers. And if I move into the power generation, in PDO we have a couple of different types of power generation on how the power is generated and how it flows into our network. So we have the open cycle gas turbines, which are the old generation units, the open cycles, the frame sets, and we have the closed cycles gas turbines as well. Most of the open cycle gas turbines that we had in the past, we converted them to the cogeneration unit or the closed cycle gas turbines, just to improve the efficiency. And with that, we improved the efficiency from 32% all the way up to 55%. And this is just to move in terms of the sustainability and reduce the emissions. As well as that, we have the cogeneration units. As you know, this is specific to PDO or the oil and gas industry, where we use the not just the electricity, but also the steam that is injected in order to enhance the oil recovery. And this is what we mean by the cogen. So thus, some of those are must-run units, where we cannot just retire or neglect, but they have to feed in and be there in the system as well. In addition to that, we have recently introduced the renewables with Amin Solar Plant as the first solar plant, not just in the country, but it was at the time the first IPP plant with the soil off-taker as oil and gas company. So from Amin and the way how we've started, we've developed the power system strategy in alignment with the BDO strategy as well, because as we know, the landscape has changed. So it's not about just maximizing the oil and gas production, not about the profit, but also about the planet and people as well. So we had put more effort into the integrating the green energy into our network and overall in the overall Oman network. So as a statement, it's targeting to increase the renewable energy capacity mix from 10% at the time when we had Amin up to 30% by 2026, which is next year. And we had a set of renewable plants that are already targeted into that, and we have awarded those projects. As well as that, we had been exploring other technologies that can maximize our renewable as well. So we had looked at future technologies that are already in the market, but not yet here in Oman, like the storage technology, for example, CSP as well. And all of that in order to aim for the net zero emissions by 2050. So in terms of strategy, we have split it into two. We had the short-term goals, which is in the near term up until 2026. And we had fixed goals for it. We have identified the technologies that we want to integrate, as well as the locations and capacities. And we came up with the North Solar Storage Project, Riyah 1 Wind Project, and Riyah 2 Wind Project. All of those account for 300 megawatt. And in addition to Amin, they bring the total renewable capacity in BDO to 400 megawatt. So this is enabling us to meet the 30% target by next year, as well as we have the long-term goals where we look into importing the green energy or the green power from the government grid, as well as the looking into the other renewable capacities and how we can tackle the limitations in the grid in order to meet that and maximize our renewable projects. So late last year, we have awarded the 3 projects, and we've known those capacities earlier on, but we thought that we bring other added value to it, where we had it as the first DBOOM projects to be awarded under BDO DBOOM standard. So we have developed a standard for an IPP projects in BDO, as well as we had them as the first ever projects to be awarded to Oman's national champion, as we all know. So we had OQ named as the national champion for the renewable projects in the country. And those BDO projects were the first projects to enable that coming into place. As well as they had the biggest projects that contribute towards BDO decarbonization journey. And I leave you now with a media video about the 3 projects award.
At PDO, we are committed to supporting Oman's energy transition by embracing sustainable solutions and reducing emissions. By 2026, over 30% of our power shall come from renewable sources. Through partnerships and innovative initiatives, we are contributing to Oman's journey toward a greener future and net zero emissions by 2050. The North Solar Independent Power Producer Project is the second solar project for PDO, developed by leading renewable energy companies and supported by PDO, will deliver 100 megawatts of peak solar energy using advanced single-axis tracking technology. Located at Saykhni Haida, it is set to be operational by the second quarter of 2026, providing clean energy while reducing CO2 emissions by over 220,000 tons and saving millions of meter cubes of gas. This project demonstrates how collaboration drives innovation and sustainability. The Riyadh 1 and Riyadh 2 wind farms, developed by independent power producers, will contribute 200 megawatts of renewable energy by Q4 2026. These projects, strategically located in Amin and Nimr West, convert Oman's wind resources into sustainable electricity while reducing CO2 emissions by over 740,000 tons and saving millions of meter cubes of gas, complementing solar initiatives and diversifying the nation's energy mix. By supporting innovative projects like these, PDO is helping to power Oman's green energy ambitions. Together with our partners, we are fostering a sustainable energy future for the nation and the generations to come. PDO, proud to serve Oman.
Yeah. So that's it. In terms of the IPP projects, all of the three projects are listed in this slide where we have shown all of the details, the technical details, as well as the gas savings, environmental emissions, as well as the capacities. All of the three projects should be coming into picture by next year, where we had the COD dates for all of them, stretching from Q2 for the solar and Q4 for both wind projects. In addition to that, we had a focus on the ICV. So knowing that those projects are going to the national champion, enabling Oman national champion to have a foot into the renewable energy within the country, and the meeting both PDO and the Oman vision targets, as well as the all alignment in terms of the capability development and the materials manufacturing and supply. That's it from me. Thank you very much.
Thank you, Walid, for sharing the important journey of PDO towards renewable energy integration. And with that, we conclude the individual presentation, and we will move to a panel discussion. I would like to invite the panelists to join me to the stage to have a closer look at the key points that we have just heard, and we talk about the challenges that we face, and also we explore what the future might hold for our industry. Please join me here. Okay, so I prefer that we start with the audience first, so we give them some space or room to ask any question before they leave, and then I'll ask a question from my pocket. So please provide your name, affiliation, and if possible, make your question so brief and specific to the dedicated speaker. Any questions to the panelists? Yeah, I think we have, okay. Go ahead, Hilal.
Assalamu alaikum. Actually, my question to OBWB, the presentation, how you control the shadow as you are using the wind turbines, structure, as also the sun is moving, because it's moving from north or to south, whatever it is in the location. how you control this shadow on the panels itself?
Thank you very much for the question. So the shadow will be minimized by setting a buffer. So you have an area around the turbines that you cannot put any of the solar panels. So this buffer area is around 500 meters, while the tower height is 170. That would minimize the shadow effect to a minimum of a loss of 1 to 2%.
Thank you, Thuraya. Any other question? Okay.
Hi.
Until the next question, I have one. Yeah, there is another question?
Yes.
Yeah, go ahead, please.
Hi. I am Vaishnav from Hamad Engineering Services, engineering consultancy for electrical design. My question is to Mr. Walid. I would like to know, is the power generated in PDO will be consumed within the PDO requirement, or is it going to be connected to the national grid?
Yeah, question to Walid. I will repeat the question. He would like to know the power generated by the IPPs. It's going to be connected to national grid or PDO internal grid. Yeah, go ahead.
So the projects are connected to PDO grid, and in terms of tariffs and all would be through PDO. But ultimately, and the aim for them is just to offset the power consumed by PDO. So this is solely for PDO operation. But as we all know, that PDO grid is interconnected with the government grid as well.
One more question. Since these two are D-Boom developer are developing these projects, would the equipment suppliers and the consultancy has to go through as a PDO approved vendor list, or is a D-Boom vendor list from outside?
Yeah, so this is a D-Boom project. It doesn't have to align with PDO AVME, except for the equipment that are interconnected between PDO and the IPP plant. And as well as that, we have the MFS, minimum functional specifications, that all of the equipment had to have a minimum level that they need to meet.
Thank you.
Okay. I will ask one question. Okay, you go ahead, Rizza.
Assalamu alaikum. Good afternoon. This is Abbas Al-Fati. I'm also PDO. A few questions. One is for Thuraya, and the other one is for Jose. I'll start with Thuraya. My question is, so thank you so much for the presentation, and well done as well. The study case you demonstrated, and you have provided some data in terms of capacity for both hybrid solution, wind and solar. So do we have an off-taker or a client or a customer that makes use of that such supply? Do we have identified the demand? My second question, just as a follow-up also, in terms of the fact that, yes, wind is active at the south region of Oman, while probably it's more scattered for the solar. And it's quite clear also the main or dominated load is on the northern side of Oman. So how would you overcome the challenges of transmission of the energy supplied from the wind towards the north side? Or are you planning only to focus the wind generation for the south-related demand?
Thank you very much, but I didn't understand or I didn't hear correctly the first question. So it was about the suppliers for the wind?
Correct, yes.
So in our tenders, it's an open tender, and the supplier for the wind will be nominated by the developers. So the developers are free to nominate who are the suppliers as long as they meet the criteria that we set. So we set a criteria that they have to be a proven technology. It has also to be operational for a number of years or a duration that we set in similar conditions. And by specifying similar conditions, we mean desert conditions. In relation to your second question, the data has proven that even in the south of Oman, we have a clearer sky and we have a higher potential of solar. So solar is not an issue, and this is, and honestly, Oman is blessed with this being one of the regions where we have both potential in one site. So both wind and solar are high in potential in Duqm area. We're not having any issues when we've done the simulations, and the data is publicly available for any developer who wants to see the data. It would be clear that we have both of them, especially in Duqm and the other sites that we've done the wind resource assessment. In terms of transmission, we have the 400 kV line that has been done by OETC to transmit the electricity from the south of Oman toward the north. However, as just a parameter that we take into consideration and just a strategic decision, we try to keep the plants toward as close as to the demand to avoid additional costs. Duqm is becoming a hub, and there are a lot of customers that has been requesting large loads that we need to serve, and accordingly, the transmission from Duqm toward the north or south is not issued using the line, as well as the load being consumed locally. I hope that's clear.
Thank you so much. May I ask a question as well to Jose? Well done as well. Thank you so much for presentation, and I personally look forward for the success of this project at the large scale capacity for the CSP plant and all the associated thermal storage. My question is more into when it's on operation, yeah? And I understand because it's very important and crucial to look at it even from the design and engineering side, how things will be during the operation. So have you considered on a scenario when the thermal energy storage, as you have mentioned, it's going to be running on 15 hours per day. So that's an important factor to help compensate when the renewable side of the solar is not available. But what happens in a scenario if the molten salt meets the freezing point? How would you overcome that challenge? And not only in particular, also when you're having a plant shutdown, for example, or maybe sudden shutdown, how would you be able to overcome restarting that plant and continue supplying the energy from thermal side?
Thank you for the question. Regarding the project, we have been, I personally was involved in the design at the beginning, the conceptual design of this project during 2017 and 2018. Then the project started the EPC phase, where we are having an EPC contractor doing the engineering, procurement, and construction. The project is in operation, the full project, the tower and the 3 parabolic trough plant. The last unit was started the operation last year in February 2024. The operation is going well, okay? And we have, with the molten salt, the problem you mentioned, that below 240 degrees, the molten salt are becoming solid. Then for that, what we are doing, we are preparing in all the piping, we have the heat tracing, and this is working very well. And also in the molten salt tanks, at the end of the day, when the plant is not in operation, imagine you need to do a plant outage of 1 month, for example, for the steam turbine, because you need to do this kind of outages to do the inspection in the steam turbine. Then in this period of time of 30 days of shutdown, the molten salt are located inside of the tanks. We have also heaters there. In case of the temperature of the solar becoming close to 270 degrees, then the heater are starting to operate and increasing the molten salt temperature. I would like to say also that the insulation of these molten salt tanks are very, very sophisticated in terms of that we are losing only 1 degree per day. Okay, then you have the salt in the tanks, within the tanks, the losses are very low. And for example, you have the tanks at 300 degrees, you are going to reduce the overall temperature of the salt 1 degree per day only. But again, if the period of the shutdown is longer, you can also activate the heaters within the tanks and you heat up the salt. Okay.
Thank you, Jose. Maybe I will move to engineering, Haytham, and then we'll come back to you, Jose. Another question? Okay.
Thank you for that.
Thanks for the presentation and the fruitful discussion. My name is Ashraf Omer from Hitachi Energy. I'm sales manager for power quality solution, mainly for the industrial application. My question to Mr. Haytham, regarding the green hydrogen, all of us know that Oman is focusing more on the green hydrogen and to be one of the leader nation all over the world. So may I ask you in specific about the green steel application, how you see the market in the future, and if there is any real steps taken in specific in Oman? Thank you.
That's a good question.
So you're talking about green hydrogen in general. So I think Oman took a bold step since 2023 when they announced the strategy. I think they announced the 8 consortiums already. They produce about 1.3. That's the target for 2030. So there is already a huge demand in the market internationally. But if we're talking about locally, there is a captive already market for hydrogen because especially in Soharbi, in the industrial area, we also produce about 500 tons of gray hydrogen through SMR currently. So we easily can convert or transit from the old fashion of producing hydrogen into the green hydrogen or even a blue hydrogen using the CCUS. So yes, I think during the last 2 years, the market is really dynamic in terms of the total or the demand, especially in the European side. But our focus in Sohar, for example, is to maintain and to support the industries to transit from the fossil fuel into the more greener energy, especially the energy, the steel making projects in Sohar port, because again, they also export in their final product to European countries. And if you may aware of, also CBAM is coming in the picture by 2026, which will add a premium on also the price of the steel that's exported to the international markets. So yeah, I think there is a captive demand within Oman, but also there is also an international demand for green hydrogen.
Complement Engineer Haytham, the same topic. Building a local supply chain for renewables is crucial for energy securities. So from your perspective, what do you think are the bottlenecks or what are the gaps that Oman national industry that's facing today? What are the main challenges that we are facing in terms of supply chain?
I think one of the main enablers, I would call it, is the policy. Once the policy is clear in terms, especially when it comes to the ICV, that's the main enablers to maintain the value chain and the supply chain of these high-tech industries within Oman. And I would be really specific in this topic because we need to have this support from the government that the developers, for example, the 8 consortiums that have already signed the agreement to produce the green hydrogen, they have to source these type of components locally first. So that would support also the manufacturers here in Oman to sell locally. And then they look into the international supply. So I think the main enablers here is the policy, and specifically in terms of the ICV.
So I conclude that as policy is the main key here to expedite and accelerate this process. Okay, my question to Mr. Peter. From your experience in European markets, what key mechanism can help the Gulf region effectively integrate renewables while maintaining grid stability and fair market pricing as well?
So if I understand your question correctly, you're thinking about the cost implications.
Exactly, yeah. That's part of it, yeah.
Part of the challenges to the grid for dealing with the renewables.
Yeah.
I know in advocating these market-based solutions and the creation a market in green certificates, green contracts, alongside commodity contracts, we always have to bear in mind the technical constraints operating for grid. And I might say the same goes for gas grid operators. If they're asked, for example, to bring in a co-blending of hydrogen. So there are technical limits. We've heard a lot in this session about grid stability, harmonics, challenges in frequency, control, management of reserves, management of reactive power. So I appreciate that with an increased penetration of renewable electricity, these things become more difficult. I'm convinced, and I think the experience so far in Europe demonstrates that the market is compatible with the continued safe operation of the grid and can actually enhance security of supply ultimately without due risks to consumers.
Thanks for that clarification. Maybe we go with the Jose. You mentioned about the energy, Noor Energy in United Arab Emirates. That's a really very big project. My question is, what are the surprise and the challenges that you faced in that project? Because when I saw the video, I saw that the heliostats, they are not directly facing the tower. So some of them are out of orientation.
Good question. In this kind of projects that are very large with new technologies, always you have some challenge to overcome. But the video is during construction. That's why, okay? The project currently is in operation. The molten salt tower specifically is operating well. We are reaching the nominal capacity, 100 megawatt. We are operating 15 hours of storage during the night. We have had a lot of consecutive days of operation, and the focus into the receiver is very smooth. Okay, what are the kind of challenges we have had in this project? During the construction, one of the main challenges came because the construction have in the middle of the period the COVID. COVID was there, and this was delayed the project 1 year, basically, because we have problem of movement of the people. We need to understand also in this kind of project, we have a peak of 10,000 people working in the project at the same time. And then it was an important challenge of during the construction this. Then after that, during operation, we are at the beginning having a ramp-up period, no? Where we are starting to put all the facilities in operation and increasing the performance. You know, normally we're having this project a performance model that you need to reach the expected performance, and then we are in the first 2 years you are always going to reach the 100%. And the facility you saw in my presentation, I projected 2 graphs. The operation during these days were very good, and we are reaching really good performance. In one of the projects, for example, in parabolic trough, we are reaching more than 40 consecutive days of operation. This technology is good for 2 main reasons: storage and then grid stability. You know, we are bringing also all the harmonics, all the needs for the grid as a conventional power plant. Okay, thank you.
Yeah, thank you. Okay, we don't have room for more questions. Okay, with that, we conclude this session on sustainable energies, renewable and storage. I would like to really thank our panelists, Haytham, Jose, Thuraya, Sarvanan, Peter, and Walid, also the audience who stayed here until this time. On behalf of IEEE and the organizing team, thank you for being part of IEEE PowerTalks 2025. Let's continue driving innovation and sustainability forward. Have a safe journey, and we look forward to seeing you at future events, inshallah. Thank you.
Thank you. Now for the certificates, Bashmans Khalfan al-Batamani, please come to the stage.
Okay, Haytham.
Haytham.
Haytham Ameri. Jose. Raya Al-Wahabi. Mr. Saravanan. Peter Stiles. And last but not least, Walid Rashahi.
Thank you, Dr. Mazen, also for managing the session. Here is a trophy